Unlisted?
Public.
Okay. Publish. Okay. And then go to channel.
I am here, but oh yeah, here we go.
Amazing.
Amazing. Perfect.
Okay, we have your volume turned on. So good morning, good morning, good morning in the lecture hall.
Yeah, I can hear you. Thanks. Perfect. Okay. Perfect. I'm gonna let everyone in. Okay?
Awesome.
Yep. Okay. Awesome. Thank you, Thomas.
Yeah, very welcome. But I think I turned down the music just in case that there are any lights.
I can keep the live stream now? On the...
Yes.
Okay.
Perfect.
Thanks for the help with that. Appreciate it.
Oh, this looks ugly here.
Oh, yeah. We can...
On the other side.
Worship. Guten Morgen, willkommen. Welcome all to OFT number 4. Round of applause. Woo! Super stoked to have you all. From myself and Andy, the incredibly powerful two-person team of the Objective-C Foundation. We just want to personally welcome all of you. I know many of you have traveled far, some have traveled short. I know some of you have taken off time from work, your studies, so we really, really appreciate that you are here today. I know many of you know a bunch about us, but for some of the newer faces, newer attendees, briefly want to mention what our foundation does. Obviously, we do conferences like this one, OFTW. These are the more student-focused, shorter ones. We also have the once-a-year longer OBTS, Objective by the Sea, Apple Security Conference. One of our core components is also creating free open source security tools to protect Mac users and also use those as educational resources for those wanting to learn more about designing security tools for Mac OS. Also the books. You got a copy of my first book. The foundation supports my writing and allows us to make those books freely available for students and many others. We also have, more recently, the Objective We initiative. This is our initiative to try to make the tech space more inclusive, more welcoming, more diverse. So a lot of our student and diversity efforts come out of that program. Now, we do have a brief video that really explains a little bit more about these conferences, but also OBTS. Many of the attendees of the OFTW, the smaller conference, end up coming to the OBTS security conference, which we love, either student scholars, speakers, attendees. So a brief video about that.
Thus far, and I do digital forensics, specifically with Mac and iOS devices.
My name's Jaron Bradley. I work at Jamf.
Michael Sosonkian, I'm a security researcher.
My name's Erica Nornberg, and I'm primarily a malware reverse engineer working in incident response.
I first found out about OBTS from Megan Carney, who I believe spoke at OBTS, and I was at Target. And it was right when I was starting into macOS, and I was told that OBTS was the conference for macOS.
In my past career, the places I've worked at, I was always the only Mac guy. There was no other Mac security guys on the team. There was nobody there. So if there was a problem, if there was questions I had, there wasn't somebody to lean on or be able to talk to.
The timing is definitely right. Macs were becoming really popular, so there was a need for a security conference that was focusing just on Mac and Apple products.
Yeah.
So we knew that piece would be successful. I knew that piece would be successful. That's my area of expertise. And then Andy really had the vision for the community. And I think that's why we're this great team, where we both bring unique viewpoints to that, where I understand the technical stuff, you understand the people stuff. So I do the computers, you do the people, and then we bring them together, and that's why people keep showing up.
Yeah.
This is my strong dude, and I'm like, man.
We are finishing this event.
Well, Objective by the Sea was the first conference I came to where I immediately felt like I belonged here.
Because the landscape is always changing, it's really important to have this close community and network of people that we've, it's family now,
People to come together, share the different research they're doing on, specifically on Mac. Prior to the conference existing, you could go to different security events and maybe catch one talk about Apple devices and what research people are doing on Macs and iPhones and stuff like that. And Objective by the Sea kind of created this big community.
And normally when you get to conferences, like you're nervous and like you feel like everyone's kind of judging you, but not here.
Conference tends to be a reflection of the creator. I don't know Patrick that well, but I do know that what comes reflected across is this appreciation for community, a desire to give back, and like an open environment to just show up as you are. And I think that's kind of what creates the atmosphere for such a diverse setting. If you don't have this engaging, collaborative environment, you will never bring people together. And like that's what OBTS does. There is a difference between like InfoSec in general versus macOS security. And I believe OBTS is part of the big reason for that difference. You'd see that in the diversity that's represented here. So.
Awesome. So hopefully that inspired you to put at least the conference on your radar. It's a great conference. Yes, it's pretty technically advanced, but it's still welcoming to everybody. So we'd love to see you all at OBTS someday. So objective for the week, as I mentioned, it's our smaller, more student-focused, more entry-level conferences, 2 days of training. Many of you were in the trainings yesterday. That was great. I heard a lot of really positive feedback from that. Today we have talks from many of the, well, world's top Apple security experts. So really excited about that. We started objective for the week in San Francisco. The second one we did with MacPaw in Kiev. Woo! After that, we did London, and now we are in Berlin. So super stoked. And we have plans for other places. Stay tuned. Brief recap from yesterday. I know many of y'all came with us to the special event. I want to thank Andy for helping plan that. Really cool, some awesome photos from that. So thank you all for braving the very hot temperatures. It was a blast. So today's schedule, we are currently in the kickoff talk. We are then going to start with some really neat talks this morning. Around 12:30, we are going to break for lunch. You should have got a lunch certificate voucher. You can follow us to go to the cafeteria where lunch will be served. We will then have 4 more talks in the afternoon. We will then have a short break, followed by a happy hour and panel, where we will have some researchers up here answering some interesting questions. And you will also be able to ask the researchers questions about careers and AI and all the things. So definitely stick around for that. Important links, if you go to the objective-c.org website, we.html has a lot of the content that I've talked about today. Also, our Discord channel is a great place to connect, both for happenings during this event, but also it's where we have a lot of our larger community. So information about the OBTS security conference is posted there. People post questions about malware, research, and share, so check that out. Once you connect to the server for today, if you go to Objective We OFTW4, that's kind of the channel that's specific for today. We also have a YouTube channel, the Objective-C Foundation. We are live streaming the talks today, so if you have friends who couldn't make that, coworkers, feel free to share that as well. Also, this is where we will post the talks from today if you want to follow up. We also want to thank you for our support. As I mentioned, we're a team of 2, which means we don't have dedicated marketing, social media. So any tweets, LinkedIn posts you post really mean a lot to us and really help get the word out. Helps us, our sponsors, the community. Super, super stoked. Just tag the Objective-C Foundation, either on LinkedIn, Twitter, anything like that. Spread the word. Fabrice, one of the attendees, posted a link in the Discord channel. I think it's to a Google Drive, where if you have your own pictures that you want to share, you can add to that as well. So we're just kind of collecting content there that will be available to you all. And that is a wrap. So I'm going to get off the stage now. For the first talk, I am excited to introduce Sanju, who's going to be talking about evasive iMessage attacks. She's been doing a lot of really interesting research on this. I know Apple has been paying close attention as well. So round of applause for our first speaker.
Okay. Great to be here. Great to see all of you again on the second day of this very nice conference. I'm happy to start this day with my talk on skip the Mac, hit the iPhone, evasive iMessage attacks. So let's see what this is all about. But first of all, I'm Svante. I'm doing my PhD here at HPI, and this is also the reason why you saw me doing all kinds of organizational stuff during the last day. And my PhD is actually on security in cellular networks, so everything related to networks, but also phones. Sometimes I just say I spend my day on the phone, which is, of course, only true from a technical perspective. But let's start right into it. So why do we care about iMessage? I mean, of course, a lot of people in this room are interested in Apple and Apple products, so yeah, but seriously, we actually had a team of PhD students and postdocs teaming up for an academic paper on iMessage. So let's look into it, why this is an interesting research target. I mean, most of you probably have at least one smartphone with them. And you also know that your phones hold all kinds of data, all kinds of elements of your personal life. And it is such an essential thing in your life that living your daily life without your phone is basically impossible. But of course, using your phone also creates quite some data footprint. And we know there are attackers in this world who are very interested in getting a sneak peek into what certain users are doing with their phones. Because, you know, if you know what somebody is doing with their phone, you can already learn a lot about their life and infer a lot of things. So one of the most extreme examples we see in the world is spyware, which is used to permanently survey people and just track whatever they do with their phones. And even though you might see some spywares being marketed as tools to find criminals or help for the good, there's also a lot of public information about this, that we have many deployments at journalists, human rights activists, or politicians, which are clearly not for the good, but more harming freedom of expression and sometimes even threatening their life, because we see there are spyware attacks and people get killed afterwards. So this is basically not what we want to see in this world. So just getting back to this data aspect of that. What we can infer from just observing the regular phone usage is we can see the location of a user, where people work, where they live, and what places they go to, where they do their sports in the afternoon, or what they do in the free time. Of course, we see network traffic they create with their phone, which is also interesting in some cases. And we can infer the social network. So who are people collaborating with? So especially if people are interested or attackers are interested in finding out what activists are doing, it's very interesting for them to see what other activist groups a certain person is communicating with. And also, of course, if you as an attacker could read messages of a person, you could also get a very close eye on their opinions. So this is already quite a bit. And of course, we know that attackers really like remote attack surfaces, because those you can use to attack a phone from far away. And one option for this are messaging services. And we've seen in the past like phishing SMS coming in, and there were cases where links of the predator spyware were just spread by SMS. Or we had cases where people were added to some WhatsApp chat group, and then there was a malicious PDF sent in this group, which got parsed automatically by WhatsApp, and in the end, some spyware got installed. But looking in all of this, so what's the difference now between some general messenger app like Signal or WhatsApp and iMessage? So for this, we need to get a closer look into iOS. So for Signal and WhatsApp, those are apps living in their own app sandbox, which we can see here. So everything, every piece of their functionality is inside this sandbox, basically. But on the other hand, if you look at iMessage, just to get iMessage to work, there are several daemons involved, so several system processes, basically. And I just listed some of them to make this more tangible for you. For example, there's Blastdoor, which is basically responsible for unpacking messages before they actually end up in the app, which is already a security measure. But then we have like a service which is responsible for identity lookup, so to get the right key material to ensure the end-to-end encryption of the message. And then we have another daemon for attachment encoding. So if you send a picture or a video or just a large amount of text via iMessage, this is handled as an attachment. And for the attachment, there's a separate daemon uploading and downloading, decoding and encoding the attachments. And even the actual message transfer in iMessage is handled in a separate daemon. So when you look at this, you can already see if you were an attacker, there's differences in just how those systems work. So the attack surface is very different. And in iMessage, since it is deeply integrated into the iOS system, yeah, we can see that there's quite a lot more to find there. Or there might be quite a lot more to find there if we try to attack one of those systems daemons. So what I brought for you next were some attacks we saw in the past on iMessage. So the first I brought here is so-called forced entry attack. This was a zero-click attack, so it just happened in the background. The user was not aware of it, did not have to click anything. And in this case, actually, malicious GIF image files were sent around. And the researchers who discovered those attacks, they found out, okay, this was something looking like a GIF, but actually it was a PDF file, just disguising. And what the researchers saw, they saw a lot of crashes in this daemon being responsible for attachment encodings. So, because, yeah, exploits at some point also create crashes. So this is how they actually found out what component of the system was attacked. And so what we had here was that actually inside this PDF parser, there was an image renderer, and this was one of the components which got exploited in this exploit chain. And on the other hand, what we could see here in this forced entry attack is that all of this was a Blastdoor bypass. So Blastdoor, the component which was meant to unpack all the messages and to put some more security into the system, was just bypassed by the exploit, which is, yeah, quite a bad thing because like this, it couldn't really work. And yeah, in the end, after like executing a whole exploit chain with exploits here and there, they got code execution on the phone and could install some spyware there. The next attack is actually somewhat similar. This was called BlastPass. It was discovered in 2023. This was another zero-click attack. And in this case, the attackers were sent passkit attachments. So passkit, this is used for the Apple Wallet. So this is basically what you see on the Apple Wallet if you have some ticket there for some concert or whatever. And those attachments included malicious images. And here, the researchers who found this, or who analyzed the phones which got hacked in this case, they saw a lot of Blastdoor crashes. So here, actually, the security mechanism at least worked in the sense that it really got to work, but yeah, still, the attackers could get around it, but we still got a lot of crashes here. And having those malicious images inside the passkit files, they exploited a WebP image parser inside the chain. And so they kind of exploited iMessage, Apple Wallet code, and image.io to get the code execution on the phone. The last attack I would like to show you here is so-called Operation Triangulation. This was also very interesting because there the security company Kaspersky was targeted. So, which is also interesting that attackers target a security company, which is actually building products trying to protect the world. So, interesting target for sure. This was also a zero-click attack. And in this case, the attackers sent watch face attachments, because if you have an Apple Watch, you can just change the watch face by other watch faces to make it look nicer. So they sent around this. And actually, they did not at first see that the phones got hacked, but what they saw was malicious network traffic flying around. So they saw that the phones connected to weird servers. And so then they started analyzing what happened there. And if you really analyze this to the ground to see what was going on there, then they found that some font parsing library was exploited. And of course, then they had the whole exploit chain again, getting them code execution there. But I talked already quite a bit about exploits, so let's get us all on the same ground as to what all of those terms just mean. So exploits usually run based on unpatched vulnerabilities, which are most often unknown to the vendors, which is one reason why they are unpatched. So those vulnerabilities are very device-specific, and often exploits are not 100% reliable, which is the reason why we see crashes. But the idea of attackers is also to stay stealthy, so they really try to reduce the numbers of crashes their exploit creates on the target device, just to make sure that basically users do not really realize that they got hacked. And also the thing is, with Blastdoor, Apple kind of created this security mechanism, for example, protecting iMessage messages. But Blastdoor has some kind of extra feature that if it crashes in a certain way, it automatically reports this to Apple. So Apple might get some hint about what's going on there. So this is also something attackers for sure want to avoid, because if Apple knows what's going on, then Apple can go ahead, try to find the vulnerability and fix the bugs. So to prevent the exploits from actually getting applied to some phones. And from an attacker's perspective, what do we need to do if we really have some device-specific exploits we want to apply on some vulnerabilities? We have to fingerprint the devices. So we have to make sure that we find out what kind of devices the users have and what operating system version is running on it, to make sure that they only run their exploits on the devices which are actually vulnerable. Because if you run it on the wrong device, usually, yeah, you don't hack the phone, you just crash it probably. And only 2 weeks ago, the security lab of Amnesty International pushed out a new report about the Pegasus spyware. And they explained it, so it's quite interesting. They explained a lot of the background on this spyware. And what they also said there is that Pegasus, if some customer gets it, they also get some management interface. And they can use this to fingerprint the target's devices. So there they even list how the Pegasus software does it to find out what kind of device the user has to make sure that they apply the right attack to hack the phones. And the thing is with iMessage, if you fingerprint a device with iMessage to find out what kind of hardware and software it is running, then only Apple could see that and not the user. So you as a user, yeah, you can just let it happen. There's not too much about it. And you will see later on why this is the case. But coming back to the attacks I talked before, let's look at operation triangulation, because this is very interesting how it was discovered, or the process of discovery. And this was also one of the motivations for our research. So I told you Kaspersky was targeted, and they had some malicious network traffic, and actually they had a tool for scanning the network traffic, which was alerting. So they looked into this, and they saw, OK, we had iPhones which downloaded some attachment from iMessage before they connected to those weird domains, which looked suspicious. So they knew, OK, if we have some iMessage issue here, we can just set up a Mac Mini and put in the targeted iMessage account, so the targeted Apple account. And like this, it would be easier for them to see what's going on, because on the Mac Mini, you can run debugging tools like Frida and to see what kind of attachment is coming in. So that's what they did. And then they waited, because they knew the attackers are sending the attack messages every now and then. And then they saw this. So the message was only hitting the iPhone, but was not received at the Mac. So the question is, OK, why don't we see it on the Mac? And I mean, they did not look further into it. They were like, we don't know why, but let's try to find out what's going on here. So they focused on the iPhone. But for us, this was like, okay, apparently you can run your exploits just on the iPhone without hitting the Mac. So what's going on here? For this, we first have to take a quick look into the iMessage protocol, because iMessage is end-to-end encryption, end-to-end encrypted. Probably all of you know that. And if we have a sender who wants to send some message, the sender first issues, or the sending device, without the sender knowing this actually, in the background, sending some identity request to the Apple server, and the server responds with the public key material of the devices of the receiver. Because like this, the sending device can actually create messages which are encrypted for every receiving device and send them to all of the devices. And yeah, as we see here, the receiver receives the message, but also our sender receives the message on other devices. But of course, the sender doesn't get a notification on their iPhone if they were sending a message from the Mac. That would not make sense, but we just want to make sure that the chat history is the same on all devices. So that's why I just send to all devices of the sender, but also all devices of the receiver. Okay, so this is the first step, but let's look a bit closer into the Apple Identity Service to understand what operation triangulation really did in this case. So upon this first contact, the MacBook queries the Apple Identity Service with the ID of the receiver, which is the email address or your phone number, whatever you use for your Apple account. And then the Identity Service returns this public key material, but also a list of so-called capabilities. And those capabilities indicate what features are supported by the respective devices. Those can be like cryptographic features, what kind of encryption do we use here, parental control features, is there satellite communication available, or does this receiving device support polls or animated emojis or whatever iMessage feature you can think of. And why do we do that, or why does the system do that? This is just to ensure that the messages can be sent to the receiving device, and the receiving device will just be able to decode the devices. So it's basically a compatibility feature to make sure that if I send a message to your iPhone 12, it still will be able to decrypt the message instead of being unable to see that. And why does Apple put up a server for that? The idea is that even if the receiving devices are offline, we can still send an iMessage which is already decoded in the right way and uses the features which are able to be parsed by the receiving devices. So it's basically independent from the receiving devices, which is also quite convenient. But yeah, when we look at an attacker's perspective, this is also maybe not the best design, or maybe at least not the most stealthy design. Because if we have an attacker and the attacker uses some custom iMessage client, so there on GitHub there are some clients available, for example, they can just use iMessage to query with the ID of their target this capability lists. And what comes back, you can see it here, some capabilities. You can already see those are basically just iMessage features. And those are coded in different ways. So some have version numbers, some are true false, some are NA. So yeah, first they get all those things, and you are like, okay, what can we make out of that? So what an attacker could additionally is on one hand, they could just query the Apple Identity Service with a lot of identities to just see what capabilities come back. But they could also include their own devices in this query, because an attacker, if they know I have an Apple account having one MacBook and an iPhone, or only one MacBook, and they query the identity service, then they get only the capabilities for their own MacBook. So it's a pretty easy match to find out what capabilities a MacBook usually returns. This was also one of the steps we did during our research, just query for our own devices and see what we get returned. And with this, an attacker can, for example, already infer the target's hardware. So if we have an Apple Watch and we get this prefers SDR equals 1.0 back, then we can see, okay, this is an Apple Watch.
of course, by analyzing all the capabilities we got before. Or if we have a MacBook and we get this show peer arrows, if it's a MacBook, it is set to NA. So yeah, like this, we can already get some information about our target. But of course, we can do a bit more, because to get like a more comprehensive data set of all the capabilities of all kinds of different Apple devices, we can query the publicly available firmware images and then extract the capabilities from those firmware images. And yeah, as you see in this picture, you can, like, for every kind of device and every kind of software version, like iOS 18, iOS 26, sub-versions, you can just get all those data, analyze it, extract the capabilities, and then you can really set up a database and see how the capabilities match to different devices. And with this, we can also see, if we just look at iOS, we see that the capabilities, the number of capabilities we have for every iOS device in iOS version just increases, which is also because they introduce new features in iMessage with every version. And actually, this graph over here is also true for for Vision OS and Mac OS and iPad OS. So it's, yeah, usually they have more features in the newer versions. So if you only get returned a very small set of capabilities, that's a hint that it's an older iOS version. And yeah, coming back to that and looking at how an attacker could use this to target single devices, because now they found out what kind of devices their target has. So they queried the capability server, and with the database of all matches of hardware and software versions, they found out, for example, that their target has like an Apple Watch and an iPhone. Then they can again use a custom iMessage client and just make sure that their exploit payload is only sent to one of those devices, but not to the other one, which is probably what we saw in Operation Triangulation, because the Mac never reached the exploit payload. So yeah, probably the attackers knew that you could debug this on the Mac and just catch the malicious attachment. So just because of this end-to-end encryption, they could basically leverage this to make sure the exploit ends up at the right device. So we can only send it to the phone and skip the Mac, basically. So of course, after we saw that, we needed to talk to Apple to disclose our findings there. So let's see what they said about that. First of all, we said, okay, hey, we have like the possibility to just infer what kind of device our target has just by reading those capabilities lists. And they said, yeah, we need this just to solve compatibility problems and to make sure that the messages are forwarded correctly and formatted correctly and that they can be decoded at the receiving end. And yeah, if we would remove this, we would break compatibility with every new feature we introduce into iMessage, or we would have to implement some complex fallback logic for that. Yeah, and they said, yeah, thank you for mentioning this. We have like some continuous assessment because of trying to have data minimization in our system. So we might consider this later. So yeah, doesn't really sound like a fix. It's more like, yeah, there might be something about it. So maybe if somebody else reports something, then, but not for now. And what we thought, one option to fix this could be to just allow this capability lookup only after some initial contact request was accepted by the target or by the receiving devices. So that it's not possible to just query whoever you want with those iMessage clients. And maybe the devices could even cache the capabilities locally and of their receiving ends, only update those from time to time to make sure that there's not a central server which just can be asked and just responds with those information. And then we said, yeah, we also have this problem that you can just target single devices. And they were like, yeah, you're right. We have like encrypted channels per device. And yeah, we need those capabilities to ensure that the devices can handle the message correctly, so the receiving end. And if we wouldn't have those capabilities, it would be impossible to deliver the messages in the correct format. So basically, they said, yeah, this is just a natural consequence of those channels. So yeah, we're like, okay, this doesn't sound like a fix. This doesn't even sound like they would think about, because they're like, yeah, we just have those channels. Sorry, we just have it there. So yeah, maybe it would be an option to check if there's a message which is only sent to one of the devices instead to all of them. And yeah, just have some central controls, because the iMessage itself is sent over Apple servers, so they are basically in the position to check for that, maybe. So what we saw in this research is basically that the iMessage system can be abused to infer a user's device, like the model, but also the operating system's version, which is a good basis for an attack, but not good if you're on the attacked end. And the attackers can use it to deliver the exploit payload to specific devices only, which is pretty good for exploitation, but not so good if you're on the attacked end. And this is probably what we saw in Operation Triangulation. And of course, we also found some more privacy issues with iMessage, which are in our paper, which will be published in November. But Apple is still considering and thinking about it, so we are not allowed to talk about it yet. So this is why I kept it like to the first part of the paper. Thank you.
We have time for one question, if anyone has a question. Yes.
Yeah, so what kind of auth is required to send these requests? Can you hit them with like a REST API endpoint? And are they like your capabilities? And how do you find your Apple ID? So like we can test it on ourselves. Is it like a HTTP REST API or something? Or?
Yeah, so actually like, oh yeah, sure. So just to repeat the question was, what kind of, is there a REST API we can just query to get all this information? So in fact, there are really like projects on GitHub like Rust Push or Blue Bubbles, it is called, which is just an open source implementation of iMessage. And since it's open source, you can already see, okay, this is how the whole system works and what requests are going out and what is coming back. And like this, your own Apple ID, you basically know from your Apple account, because when you create your Apple account, you register it with like a phone number or a email address. And this is what you can just put in there, and then you get the list of capabilities back, basically. Here we go.
Awesome. Thank you again so much. Super interesting. And thank you for going first. It's always, a little nerve-wracking. But now you get to relax the rest of the day.
Yeah. Thank you.
For our next talk, we have a former attendee and OBTS student scholar. So a round of applause for Biagio, who's going to be talking about machine learning for macOS malware detection. Woo! This mic.
I will try with you. Okay. All right. So, hello everyone. I'm really extremely happy to attend this, new edition of Objective for the Wii. This time, actually, as a speaker. Today, actually, I'm going to present some cool research about using AI for macOS malware detection. And here, first thing before starting, as you may notice, I changed the title of my presentation. Why? Because actually I'm going to talk about leveraging classical machine learning for macOS malware detection, as well as a very recent research project that I started 2-3 weeks ago about, say, leveraging agentic AI for macOS malware detection. And yeah, you will see some, say, cool introduction about that. So, well, okay, before, say, diving into the details, just some words about myself. My name is Biagio. I'm currently working as a senior researcher at Dynatrace. I'm based in Vienna, and also I got a PhD on AI security from Eurecom, a research center in south of France, in Côte d'Azur, also in collaboration with the SAP Lab France. And actually, during my PhD, I started working on machine learning for macOS malware detection, and you will see some, say, key results of my research in this presentation. Also, I dropped my contact details. Feel free to reach out if you have ideas, questions, also critiques about this presentation. Always accepted. All right, so first of all, maybe you may say, okay, cool, but okay, why using machine learning for macOS malware detection? And also, more importantly, like how to do that. So we'll try to answer this question in my presentation. And so first of all, let's start with the first one. So maybe say, as many of you already know, I mean, since many years, we assisted to a really significant increase in terms of the number of macOS malware. Like here also, I added some key numbers from the Mullock Lab. In their 2025 report, basically they reported a 67% increase in terms of macOS vector variants, 17% more stealers, with more than 80 countries affected by stealer malware campaigns. And yeah, actually one of the, say, key reasons about that is because actually macOS is predicted to become one of the, say, the most used operating systems among enterprises by 2030 by Jamf. So basically these numbers highlight, say, very important need to have robust and effective detection solutions. And well, in my opinion, say, machine learning can be one of the answers to this open problem. And yeah, so like basically these answer the first question, especially like machine learning can a lot automate detection by automatically extract, say, malicious patterns and learn malicious patterns from data. Oops. Say now let me try to answer the second question, and to do that, basically I will try to shape this presentation from a research, say, academic point of view. And okay, when you start tackling a new topic in research, especially in academia, you start to understand the current state of the art. And when I started during my PhD working on macOS malware detection, basically I found out several gaps in the current state of the art. So first of all, the lack of a state-of-the-art data set. If you want to design a very effective machine learning solution, you need a very reliable and comprehensive data set. As you can see from the, say, summary table on the right, basically previous research was using a data set with a very limited number of samples. And so basically, actually, we wanted to tackle this open issue. Second, say, most important point, actually previous, say, research, mainly detectors, were using some features, some, what we'll say, generic features inspired to the Windows malware domain, but they were basically overlooking some very important features that are, say, macOS specific, like, for instance, entitlements, certificates that can be embedded into a binary, as well as also very important persistent techniques, like, for instance, launch agents that are leveraged by malware samples. Indeed, this is like one of the very important research questions we addressed in our paper that also I'm going to show the results in the coming slides. And yeah, but last but not least, also previous research doesn't basically evaluate the detectors on especially the generalization capabilities in the wild. Also to evaluate your detector on temporary new samples. This is especially important because it's related to the so-called concept drift. So when performance of the model start to drift, start to decrease when you test them on temporal new samples. All right, so this is actually the basic pipeline you can leverage to design your machine learning-based detector. I'm going to cover the key building blocks in the coming slide. So yeah, first of all, you start with the dataset. Actually, we created, as anticipated, a very comprehensive dataset of more than 40,000 samples. They include both goodware and malware collected from different sources. As for goodware, like we collected binaries from my personal MacBook, Homebrew application, as well as some open source macOS applications that you can find on GitHub. On the other hand, for malware, we also tried different sources, like for instance, the Objective-C dataset. Say kudos to Patrick to always, keeping it up to date. Malware Bazaar, Virus Share, and like most of the samples also were collected from VirusTotal, which we also used it for, checking the labels of the samples. And okay, next step is feature extraction. So for each binary in your dataset, you extract some features. But okay, first of all, what is a feature? Basically, feature is a numeric characteristic of the input sample, in our case, Meko binary. And like we created a very, let's say, comprehensive list of features spanning from more generic features inspired to like the Windows malware domain, as well as some, say, novel features, as said before, that are macOS specific. So, for instance, macOS APIs, entitlements, persistent techniques, as well as the status of the, say, certificate chain. Why is it important, to extract features? Because machine learning models, they work with numbers. So basically, you need to create a numeric representation of the input sample. And these features can be, for instance, the total size, the number of sections, the number of segments, and so on. As well as also, say, the key novelty of this work was also to include the macOS-specific ones. All right, so next step is model training. Basically, in this step, we were mainly covering tree-based machine learning models, which are widely adopted in the malware domain, because basically they have several, say, key advantages. Like, for instance, so first of all, scalability. They can be trained, also deployed in parallel. Second, also explainability, which is, I would say, a very important property. So basically, given this model, you can easily extract which are the most important features. So those features that contribute to the final classification. And yeah, also, so basically we selected these these three machine learning models. Next step is also evaluation. So in this case, basically, especially to check the generalization capabilities of our models, we collected a new dataset, including temporally new samples from VirusTotal. This is the balanced dataset, so in total 9,000 samples. And we used two main metrics, so the true positive rate, basically the detection rate, compute when setting the classification threshold of the model at 1% false positive rate, and basically also the F1 score. F1 score basically is considered like the mean between precision and recall. So basically, you try to balance both detection as well as trying to reduce false positives. And so basically, yeah, at the end, so then you, after evaluation, you can deploy your model, and so given a new binary to classify, you extract features, and then basically you give this feature representation to the model, and the model gives you a verdict, a prediction. All right, so now some, say, key results from our research. So first of all, we compared our solution, our feature set, also with the state of the art. And as you can see, the best model is based on XGBoost. And compared to the state of the art, basically, we obtain 16% increase in terms of the detection rate, which is, I mean, pretty nice results. Now, like moving to the feature importance, basically, as you can see, considering the top 10 most important features, basically among them you can find a lot of many, say, macOS specific ones. For instance, if we like focus on the, say, multi-arc benchmarking dataset, as you can see, basically there are the top 2 most important features are the presence of the certificate and whether the certificate has been validated by Apple. So basically, if in the certificate chain there is also the Apple certificate, which I will say from a security analyst point of view makes sense because usually certificates is one of the first indicator that security analysts check because like usually like for apps also binaries downloaded from the App Store, we have the certificate. So like if it's present, it's validated, it will be likely the sample will be likely a good one. Next, also we want to understand basically whether these macOS specific features are important also to generalize over, say, new temporary new samples, new families. And like for this experiment, for this, or better, to answer this research question, we did a very simple but yet experiment. So we asked ourselves, what happens if we basically remove the macOS specific features? How performance change in this when we do so? And basically we noticed that by removing the macOS specific features, performance dropped by more than 15%. So basically this underlines that like macOS specific features are basically semantically rich and also they allow to, generalize over new malware samples. And yeah, last but not least, also we compared our solution with, say, the current state of the art. So we evaluate on this temporary new dataset, and as you can see, basically, our solution outperforms a lot, like by more 50% and 37% the state of the art, if we consider the detection rate as well as the F1 score. So yeah, actually we were, say, pretty happy about these kind of results. And actually I managed to publish this research in a paper that you can find also on arXiv, but also on the ACM website. Also, actually, we released the dataset with all the extracted features, as well as also the code to extract features, like or run the experiments. This work also has been presented to SSECS on Bangalore 3 months ago. So, yeah, pretty happy about that. So now I will say maybe the new part, or what I say added for this presentation. As anticipated, like this is a new recent work I've been working on, and like I thought, okay, this event is the best, say, opportunity to present it. Actually, open source it because I'm going to push on GitHub the first release actually after this talk. So actually, basically, this project aims to bridge the gap between agentic AI and macOS malware detection, and but say first of all, like what is agentic AI, or better, what is an agent? So basically, an agent consists in LLM or one or more LLMs, and that is connected to a set of tools that the LLM can call this tool, get say some results, and then say update his knowledge. So basically, these tools are important to expand the knowledge of the LLM. So basically, how can we use this approach for macOS malware detection? Well, actually, imagine, okay, the security analyst can say, okay, I need to analyze this new binary. You pass the path of the binary as a prompt to the LLM, and then also we need to, create some, say, specific tools to, parse, to analyze, to extract some important features from the binary, like for instance, get entitlements information, signature information, extract some security sensitive APIs, like strings representing indicator of compromise, and so on. So basically also like reusing also more or less the same features I presented before. And then basically this updates, the knowledge of the LLM about the current samples, and you can, repeat these steps in a so-called reasoning loops. This basically kind of paradigm, whoops. Okay. This kind of paradigm is called REACT. It means reasoning and acting. When you start, basically is made of 4 steps. So first one, you observe, so read current findings. Then you create a plan based on the current finding, and you decide which tools to call. Then act, so call the tool, and get some results, and then, update your current knowledge, your current hypothesis. Finally, you come up with a verdict, say, okay, this sample is malicious or benign. So this will be the last slide to, introduce this new research project called Mac Skillet. Basically, it's an AI skill, so basically a set of prompts as well as tools, specifically designed to analyze and classify macOS applications as well as binaries. Basically, it has been designed with 3 design goals. So first of all, to support multiple frameworks. Actually, it supports Claude. Also, you can also leverage local LLMs through Llama, a very known, framework for running locally LLMs. As well as very, very recently, I added also support to the Apple Foundational Model API. This is actually connected to the second design methodology, or point, to be, tightly coupled with macOS. So to leverage as much as possible, tools provided by the macOS operating systems, like for instance, CodeSign, Exatra, OTool, and so on, for spatial analyzing binaries. And also, to be also analyst friendly. So to basically return as output a kind of risk-based score, so how much the binary is likely malicious or, benign, as well as, more importantly, also a kind of fully explainable, reasoning chain, to basically to tell the analyst, okay, this sample is malicious because of, these indicators, so to provide, very detailed feedback to the analyst. And yeah, on the bottom, basically, you can find, the main building blocks of this architecture. So as tools, basically, you have 2 sets of tools. One is macOS native that leverage, command line tools available on macOS, as well as this, MacOPy, this kind of Python framework for feature extraction that is based on actually my previous research. And yeah, next step also, is actually also feature extraction. So basically, the LLM can leverage this tool to extract features to analyze the sample. Actually, the default agentic AI solution is based on React to Loop, I explained before. And then at the end, the model came up with some verdict and the reasoning chain. So to explain the analyst, okay, this sample is a malware because of, these indicators. Will be very soon open source on GitHub. Feel free to contribute. I will also, invest a lot of my personal time also on to contribute to this project. And so thank you very much for the attention. First of all, before ending, just want to say mahalo to Patrick, Andy, and the whole Objective-C Foundation, as well as I will say HPI for organizing this amazing event. I attended last year as a student, and really it was very, very inspiring. That was also, a milestone also for my, research for the paper. So really, really happy to, be part of this community. That's all.
Thank you. That's some incredible work. I love the AI piece at the end. We have time for some questions, and we have a question thing. So I'm going to toss this to you and speak into the white. I'm going to throw this in hops, so not super far. I'm going to toss this to you, and then throw it back to...
Or can I just ask one?
Sure, you can ask one first, and then we'll get back to you.
All right. This working? You said we're going back to the classical machine learning section of your talk. You said that macOS specific features are semantically rich, and that performance fell significantly when you remove them. Do you know why that is? 15% is large.
Yeah, true. That's a lot. Actually, because I think they, through these like macOS specific features, basically you can capture more, some, I would say, how new species, new families, they change over time. So, like for instance, what happens, from certificate point of view, they use new entitlements, also they capture better the behavior. That's, I would say, something that mainly discriminates between goodware and malware. Because, from just, generic, features that look at more the structure of the binary, you cannot, claim that much. Okay, the machine learning model learns kind of these patterns, but, they are less, they don't model better the behavior. On the other hand, the macOS-specific ones are more looking into the behavior.
Okay, so is it analogous to having more data points?
Is
it like having more data points to work?
Yes, definitely.
Okay. Does this mean then that if you were to generalize your technique to be, say, multi-platform, it wouldn't work as well because it wouldn't have the macOS specific features?
Well, actually, in principle, you could also extract these features. Like they will say generally platform independent, at least for the extraction part. For the still, they are still related to the macOS operating system. And I would say in general, what actually boosts performance of a machine learning model also is, to add some features that are very domain specific. You have to look at your domain, understand, which are the, problems to solve, the critical features you can extract. And I think that this plays a lot of, in terms of performance.
Okay.
In general, domain specific domain is very, very important. Sometimes it's a bit, overlooked because, especially with the new, deep learning, basically, you just throw the input inside the network and it automatically extracts. So you don't care about the domain. But yeah, also in general, I'm more, so I believe that domain in general plays a very important role in malware detection.
All right, thanks. Appreciate it.
You're welcome.
Who is the?
Hello, thanks for the talk. So my question is, you mentioned about the model train just for detection. So how do you see the cost involved in that? If each and every event has to be sent to the model to get the next step to know and then get the, result of that detection. And second one is, how do you see the context pollution if we start sending all the events to the model?
Okay, maybe I didn't got the first one. Can you repeat?
So you mentioned that the model train being used and that there is cloud API or maybe local Olama model can be used. So how do you see the cost involved in that? When we have to send a lot of events, and when we start sending that event, at some point it will collude the context of the overall conversation with the frontier lab models or maybe local models.
Yeah, okay. Well, actually, yeah, of course, usually when using, local LLM compared to, cloud ChatGPT, of course, you need to consider the trade-off in terms of, cost, the number of tokens involved. Yeah, the idea is to, trying to support multiple frameworks. I don't know, if you have a pro subscription of Claude, you want to use, more professional way, you should be able to use, to connect to those, providers. But also, I think, especially, these days also, local LLM has, underlined also very interesting performance, especially in different tasks. That's why, basically, it's also say important features to add. But also like recently also added the support to Apple foundational model. That's basically you can leverage them for free. These are basically like embedded in your Mac, and yeah, that's a very nice feature you can basically leverage to, I would say, especially save cost in terms of talk and avoid using additional API key.
Okay, understood. Thanks.
You're welcome.
Well, first of all, congrats, Viaggio, really good talk. I really enjoyed it. Fantastic speaker. I wanted to ask you about how do you see the future of LLMs integrated into current EDR solutions? At least from what I see that LLMs maybe are a little bit slow nowadays to get like fast detections. So how could you see in the future like current EDR solutions with this kind of, in the agentic era, this kind of detections?
Yeah, nice, we'll see, maybe tough question. No, okay, that's a very important question, actually, because there are many companies asking, trying to answer this question, trying also especially to integrate, some agentic AI solution in their product. Well, actually, in general, I would say, I think will be in general good features for ADR. Still, I would say one of the key problems is to, create a kind of, like textual representation of the input, which is not sometimes easy, to extract some meaningful information that can be provided to the LLM. That's, I would say, maybe a critical point. But nowadays, especially, and also especially, I think, is not say more this agentic AI paradigm is not just LLM itself. I mean, nowadays you can also leverage open source LLM, which are doing great, but also is, or the harnesses, also all the set of tools that you add on, say, on top. That I would say that makes the difference in general. So I think, especially for security companies, they should focus on expanding to have the set of tools, to analyze binaries, to create, to perform a good, reasoning chain. That's the key part. That, at least in my opinion.
Thank you, thank you.
Thank you again, Viaggio. Great talk.
Thank you.
Next up, we have a talk from a former OBTS speaker. Ksenia will be talking about click, fix, and crypto. So, a round of applause for Ksenia. No rush. Oh, thank you.
Good thing I didn't wear high heels.
Next time. Use the mic or the...
Poo poo poo. It works. Thank you. 1 second, I need to... Oh, okay, okay. I'm not Russian. I have problems with launching presentations. You remember OBTS? So I'm just taking my time a little bit. Okay.
Ukulele this time?
Okay. Should we go the entire screen? Patrick, you can sing something, I don't know. Or dance, oh yeah. Objective for the V, that's here. Oh, it's here. Oh, I have one. Sorry, I didn't see that. Okay, I'm good. I didn't want this one actually, but okay. Let us do this one then. If you see some of my Slack messages, please do not read it. Okay? We should be good with that. Oh? Okay. I go that. If I go here in a presenter view, kind of thing. Bum, bum. I go here, and I go on slideshow. Slideshow. Woohoo! That's cool. Do we have clicker maybe? Thank you for your patience. You are really great. Patrick just said to me that we have plenty of time, you can take your time, so I'm like, okay.
No clicker, though.
Where?
No, none.
No clicker. Oh, you broke my heart. Okay, here's the clicker, so I'm gonna stay here. We can start. Every great video game is built around a conflict, and good versus evil, and the world of macOS malware, it's basically the same thing. I know everyone is waiting, is looking forward to playing the GTA 6. Some people even about to get a day off from work. So that's why I decided to make such a presentation for you. And yeah, talking about games and macOS malware world. The stakes are just as high, and the map is just as messy, and the fight between good guys and bad guys never really stops. And today, I want to walk you through that world, through the eyes of people who build this stuff, I mean malware, and the eyes of the people who hunt them down. Mostly the second one, because that's my job. And hi, everyone. My name is Ksenia. And today, I'm that one character you gonna play with. So, that's not really comfortable. Yeah, as I said, it's a little bit about her, about that character. She's a malware research engineer at Moonlock by MacPo. Moonlock is a user-friendly antivirus app for Macs. And she's Ukrainian, as you can see on the slide. And you can find her in Twitter by handle OSINTBarbie. And her day job is hunting new macOS malware, poking around cybercrime ecosystems, and performing some OSINT operations. She also spends a lot of time telling people one unpopular thing, that Macs get malware. They do. Now let's meet the people she's chasing. So a little bit funny. That's not their real pictures, of course. Oh my God. Sorry. Every heist crew needs a lineup, and here is ours. Suspect number 1, Mikhailo Hureev. On paper, he is a co-founder at SolidBit Capital. In reality, he is the recruiter who slides into LinkedIn messages with a compliment and a Calendly link to book the meeting. He is charming, professional, and plot twist, his face is very likely AI generated. And suspect number 2 is Anatoly Bigdash. He's not the face, he's the name. The name sitting on the WHOIS records behind all the phishing infrastructure. And are they real people, or they are stolen identity, completely made up? Honestly, I don't know. But everything traces back to these guys. And let's press start and go with the chapter 1. So here is the thesis of the whole talk. And I would tattoo it if I could, but I prefer my skin clean. Nation-state hackers don't always drop 0-day. Sometimes they just send a polite LinkedIn message. And honestly, it works alarmingly well. No exotic exploit, no Hollywood hacking movies, just good manners and a link. So our game runs on 3 missions. And let me show you all of them. So, as I said, 3 missions, and the whole talk is about them. Mission 1 is the theater. Fake venture capitals, real targets, AI-generated team pages, websites, thoughtful direct messages, but none of it's real. And it was made just to survive a 5-second surge. Mission 2 is the trick. There is about the click fix. It's the star of the show. And the victim runs the malware themselves in this situation. No exploit needed, as I mentioned before. Mission 3 is the method. And this is my favorite part, because here we're gonna talk about the OSINT. One who is record, 3 fake companies, 1 operator, and we'll go with you into fully detective mode. Best part for the good guys, as you are, I hope. I hope there are no bad guys, but can be some hackers. The tools I'm going to show are all free, and the only currency is your patience. So let's start the first mission. Go. And this is what the social engineering looks like. It's not scary, and that's the point. The real message, and you can just read it with me right now. I've been following your work, really impressive. I'm a co-founder at the fund. Trust me, bro, etc., etc. Open to next steps? My calendar is linked below. 3 red flags in 4 messages. But when it's addressed to you, by your name, about your work, your guard just drops. And that's the whole trick. So now, how do we know this is a coordinated campaign and not just one weird guy? So we know because real victim told us. On January 9th, 2026, someone who'd been targeted posted screenshots of the entire conversation online. And details were all there. Lookalike domains, pressure to leave LinkedIn fast, and my personal favorite thing, it's when the victim flipped it around and invited the bad guy to their own Google Meet. The bad guy joined. He was like, okay, good, I'll do it. He joined, sat there in silence because probably he couldn't speak, good English at that point, and just left. So yeah, he ghosted his own meeting, which is a huge red flag. Any girl will tell you. Now let's look at the companies behind him. So we can see here 3 companies. 1 operator and 0 actual businesses. Solid Capital, the legend, that's the main company we found. Google says it exists, sort of. Just enough breadcrumbs to survive 5-second search. First glance when victim just tried to find something about the company. Megabit is a kind of the backup. Again, the AI faces, identical websites, copy-paste placeholder text where the team BIOS should be, but it wasn't there. That was very weird. And the last one is Lumax Capital. The next one, domain registered 2 weeks ago, and they claim it's been operating since 2018. So, now the question. Are you guys excited to meet executives of Lumax Capital? Yeah! So let's take a look at them. That's my favorite NPC poster ever. Look at them. it's so much AI-ish that I couldn't stop laughing when I saw it for the first time during the investigation back then, a few months ago. Even my dog woke up because I was laughing so much. I was like, I was sending it to everyone, like, look at these guys. Like, they look so perfect. Of course, none of these people exist. And of course, with scary mythos, Fable, Kimi 3, pictures of the executive teams became much better now than back then in February. But still, they can be differentiated from the real ones, because real executives look tired, and AI-generated executives look perfect. And continuing the Lumax story, I can show the first free tool you can steal from me today, checking a domain's name. Of course, I saw that audience is pretty advanced, but maybe not everyone does OSINT, so yeah. So yeah, as I mentioned before, they said that the company founded in 2018 and that it's been operated since the Ethereum was cheap. But at the same time, their website proudly said, but at the same time, I checked it on Whois, and the record showed that domain's birth certificates is 14 days old. I don't know if it's okay when a 7-year-old company registered its domain just the week after the Super Bowl. I don't know, it looks weird. So that's the moment when the lie was detected, and actually the moment where we are done with our first mission. And now the actual heist, the kill chain. So the kill chain contains 5 steps, and the genius of it is that not one of them feels like an attack for a victim. Direct message on LinkedIn, booking on Calendly, a spoofed conference page pretending to be Zoom, kinda. CAPTCHA that quietly poisons your clipboard is a bad comment. And finally, a Mac user pasting a command into the terminal and hitting enter. Like, for ordinary user, it doesn't feel weird. Each step lowers the guard a little more than the previous one, and by the end, a victim has done all the work by themselves. And let's take a closer look at the step 4, the click fix itself. So the click fix, or as I like to think about that, why hack a Mac if I just can ask politely and nicely? Look at the 3 panels. What the security software sees, like user typing, that's it, just keystrokes, totally normal. What the user sees, friendly Cloudflare, I'm not a robot box, reassuring, pretty familiar, and what's actually happening. That CAPTCHA instructs the user to load a malicious command onto the clipboard, and the verification steps are walking them through, pasting it into terminal and running it themselves. The native Apple protection doesn't fire at that moment because from its point of view, nothing attacked the machine. The victim did. And hold on. Let me zoom out for a second, because this is bigger than just one campaign. And since we are in Berlin, we're gonna see some falling walls. Boom, boom, boom. And here we are. We comforted ourselves for many years that there is 2 walls. Wall 1 is Windows and macOS are separate problems, and this year showed that it's gone. Same command and control servers, same droppers, same operators, just a different binary per operational system. The server in this campaign happily served payloads for every platform, macOS, Windows, Linux. And Wall 2 is about nation state and cyber criminals are using different toolkits. It's also gone. Tactics that used to be a North Korean signature are now standard thing for every cyber criminal crew. And now we are going to a rare feel-good moment. It's the time when bad guys failed the mission and lost to a single researcher, who is sitting here, by the way. Here. He's so shy, but... So, his name is Patrick, and he's from Objective-C, and I've heard from other researchers he doesn't sleep. That's how he has time to build cool free Mac security tools. And he shipped a version of his tool block that specifically watches for exactly this move, a paste going from a browser straight into terminal and warns the user before it runs. And here's the kicker on the timeline. Patrick added this protection before Apple did. But anyways, Apple also did. And after 3 weeks, the bad guys completed their shady mission. Oh, I skipped the slide, sorry. So anyways, bad guys completed the mission, and you can tell that attackers probably read the same release notes that we did, and they just walked around it. According to our researchers friends from Jamf, instead of terminal, they now hand the user off to script editor through a URL scheme, and there you have a lure page impersonating Apple itself that links to Apple script and which opens script editor with the malicious script already loaded. A user hits play, and Apple's brand new terminal warning doesn't fire. So yeah, because terminal was never involved at that moment. So new control, new workaround, but the same outcome. And now let me show you just how convincing the decoy page was. So they didn't just spoof a random login page, they spoofed a hedge week, a real financial conference. They created a pixel-perfect clone of a real site with a fake CAPTCHA, and under the hood there was a domain zoom.us07web.us, which has nothing to do with the real Zoom, of course, and the Cloudflare check that is just local HTML with no Cloudflare anywhere near it, and the CAPTCHA's only job is to instruct the victim to infect their machines. So yeah, and that's done. Victim has copied and pasted it to the terminal, and let's see what they actually just ran. So let's take a look at the payload itself, the malware that politely tells you driver updating is started, while it just robs you meanwhile. Let's walk through the comments. We can see here it uses social engineering, as you can see. It ensures Python is available. If it's not, it installs Homebrew if missing, and then installs Python via Homebrew, which is pretty cool. You never had this, and now you have it. Cool. Yeah. So next, it downloads a remote Python script from a suspicious domain, executes it, and tries to run in the background. And what about the detection evasion? So I'm going to show you something. It was 0 out of 70. Let me explain why that matters. VirusTotal takes a file and runs it through roughly 70 different antivirus engines at once. Basically, the entire industry in one shot. And that's the standard first check any of us runs. And the sample scored 0. Yes, we should mention here that many engines that on VirusTotal, they do not show like how they work in dynamic analysis, yes, only like static, and that's the point. Yeah, and so yeah, the sample scored 0. It wasn't just one sample, there were 3 samples, all of them were 0, had 0 detects at the moment of publication. So how did we finally get eyes on it? The answer is the community. Some shout-outs to cool people. This is where security Twitter earns its keep. The sample that macOS app written in Swift pretending to be Zoom was first shared by Malware Hunter team and analyzed by Chris. You can know him as Lobsec. This is a good site of the internet. Researchers passing a suspicious file around, pulling what they see until a picture forms. No single person cracks it. The crowd does. And yeah, I recommend you to follow these guys. They're really cool. And follow Objective-C. And Moonlock Lab. So let's actually open the fake Zoom app to look at it. Here we can see the native UI, telegram exfiltration, and the attention to detail is honestly so cool. It's built in Swift with a real Swift UI password prompt. It asks for your macOS password to access your microphone or something, which is a completely normal thing Zoom would ask. And here's my favorite touch. If you type wrong password, the window shakes, exactly like the real macOS prompt does. And they just implemented this like frustration animation. And once it has the credentials, it ships them out through a Telegram bot and the same server host payload for Windows and Linux too, as I mentioned before. And when we tried to reverse engineer it, they left us a little surprise. Here, that's how it looked like. Not really nice of them to do that. And that's why it bypassed some detections on VirusTotal. So look at the disassembly. Almost every line was junk, meaningless math, instructions that cancel themselves out. In this noise, only a few lines could actually matter something, like pull the next stage and reassign the binary. And everything else exists purely to drone analysis tools in garbage. Yeah, okay, we've seen how they attack, and now let me show you how we think. Oh, back. Let's go into detective mode, as I promised you. This is the workflow, and the beautiful thing is you can run it, all of it from a student laptop just tonight to try it out. You can start with a sample, hash it, throw it at VirusTotal, pull the infrastructure, whois, the command and control domain, prompt, take that email of that registrant, search for it everywhere else, take the name, go to social media, try to search there too, map the behavior, trace the social flow from LinkedIn to Calendly to fake Zoom, etc. And finally, attribution. Compare the tactics against known, documented groups. And this is where our 4-star villain from the very beginning finally shows his face. Remember Anatoly? Let's find him. It was pretty easy, by the way. So, step 1, we just pulled, as I mentioned before, the whois records for the malicious domains, and every single one came back to the same registrant, Anatoly Bigdash. Same name, same Boston address, same phone number, and the same Gmail on every domain. Step 2, and okay, this is where I have to confess to you that OSINT is basically just professional stalking. And as a woman, I have been training for this my whole entire life because, I mean, don't laugh at me. I mean, we've all hypothetically done a little 2 AM investigation into an access social media accounts. But yeah, that's kind of same energy. I've just monetized that and put it on the business card. So yeah, I just started Googling these guys, the names. And up comes a private LinkedIn profile, Anatoly Bigdash founder, solid bit capital, and step 3, Solidbit Capital is the exact same company Mikhailo Gurev claims to co-found when he's messaging victims. And it really was a few searches that unmasked the thing. Boom. And talking about Mikhailo Gurev, here you can also see that how I also found mentioning him in posts in Twitter. And that's the punchline of the whole method. These actors will invest serious effort in fake teams, AI headshots, clone websites, and then reuse the same domains, the same emails, and the same names across all of it. And here you can find how I chased Gurev, as I mentioned before, and yeah, and that's it about OSINT. So who is the crew? Let's compare the fingerprints to a known group. Boom, boom, boom. So here we can see the comparison between our campaign and a campaign that was described by Mandian during almost the same time frame. And I would say the identity, like, it's very, very similar, and it's so much similar that it's even uncomfortable. But honestly, as I mentioned in the beginning, lately there is no much difference between state-sponsored groups and cyber criminals. So copycats, they exist, and tactics get shared and stolen, and that's why we have to be careful with attribution now. Because I can see lately any new macOS malware being called DPRK, I know, North Korean malware, and it's a little bit too much, feels like too much. We had a talk with Chris Lobsek during the podcast at 9 to 5 Mac, and we also mentioned that attribution became much harder lately due to these problems. Yeah, all right, enough about them, and let's talk about protecting you. However, I believe you know all these rules, but anyways, let me go through that very quickly. First one, never pass commands in the terminal if you do not know and do not understand them. Two, always verify the domain. Don't trust what's written on the page. A site can say since 2018, while the domain was registered 2 weeks ago, and 10-second whois check will help you. Just do it. 3, treat any urgency as a red flag, and 4, add a real layer of protection. And now, I work in Moonlock, and of course I could stand here, tell you to install Moonlock, but the real thing, and saying honestly, there are a lot of other cool tools in the market, and we're just proud to be one of them. But whatever you choose, just make sure it's legitimate and it does its job. Yeah. So that's it with rules. And almost the last thing, that's about the community. First thing, I want to thank Patrick and Andy for bringing Apple. I want to say macOS and iOS community together. Yeah, OBTS is something else, Objective for the V too, and really you do a great job, guys, and I'm so proud to be here, and thank you for inviting me. And the same mission as Patrick and Andy have, we have the same in Moonlock. We want to help keep millions of Macs and Macs users around the world safe, and I would genuinely love for you to be the part of it. And these are the side mission, and they are always open to them, to you. First thing is if you spot something suspicious, a weird installer, weird direct message, or file that makes you feel weird, send it to us. We triage everything, even the it's probably nothing once. And if you want to go deeper, come talk to our Discord with other Mac researchers. And if you just want to keep up with the latest news, follow the Moonlog Lab on X. Fresh intel, IOCs, and such stuff like that. Yeah. As always, in the end, indicators of compromise. Pa-pa-pam. Here we are. But of course, no one likes to just type in from the photo. So you can scan the QR code and read the full report here. Or, oh, that's a little bit not cool, because I was about, last 30 minutes, I was like, guys, be very suspicious, do not do this and this. Now I'm like, scan QR code. Don't do that, maybe. I'll just go with old school style and say everything you can find at moonlog.com. Type it by yourself, verify it, and yeah, you're very welcome. Thank you.
Okay, we have some time for questions, but first I want to thank again Ksenia. She drove 2.5 hours this morning just to be here for the talk, so thank you so much. Also thanks to MacPaw, who has been a longtime supporter of the Objective-C Foundation and a host of one of the previous OFT events, so we're very grateful to them. So questions, I'm going to steal the first one. You mentioned that when you analyzed the binary, there was a lot of junk instructions. Could you talk about maybe how you analyzed that binary that had all that kind of crappy code? Did you filter that out? Did you run it in a VM? What was your analysis technique? Because I think we're going to see more and more of that.
Yeah, actually, the problem is that we are very lazy lately, and we just want to go in Sandbox and see what it does there, like if there is a possibility. Yeah, and fortunately, this binary didn't have any like anti-analysis things, so we were lucky enough to analyze it like that. But it's a, may I say that word? Pain in the ass with Go files lately, especially garbled ones. You know that obfuscation is really so hard to analyze, and yeah, to be honest, we were like few days during our daily meeting, we were like, oh, all the easy malware ended. There is like only hard ones. Let's wait until our like another colleague senior came back from the vacation, and let's surprise him with that. So yeah.
Other questions?
Wow.
No.
Yeah, NBA is not for you. I know you do surfing.
You love the NBA?
Sorry?
You love the NBA? You mentioned NBA.
Oh.
Okay, thanks for the presentation. My question is a little bit related to what Patrick asked. Like, what type of open source intelligence tools do you use for your investigation? Like, in 2026, for example, if I want to join an investigation, should I go like check dark web website or Doc GPT or Doc Search Pro? Like, what do you recommend, or what would you recommend?
Oh yeah, actually, that's a really good question. Thank you. I do all things I can. Like I try new methods all the time. Yes, initially before LLMs became advanced, you had to do it with tools at work or manually even. And lately, I would say that Claude works pretty well with such cases, and you need to just do like Google searches, such stuff like that. But at the same time, I still do not have really cool tool for searching social media, which is a really good thing to have when you do humans, yeah, when you're looking for a person somewhere. And sometimes you need to create a Nails Berlin account in Instagram to just follow someone to check kind of thing. And talking about dark web monitoring, we also do that. And if you are interested in that, I can tell you after later, like how to set up the, I don't know, to set up the tools or environment, but it's not like for going to dark web asking for something, but it's like just monitoring tools that not allowed you to interact there much with threat actors. Yeah, but sometimes I had a situation then the threat actor, few of them even wrote me in Twitter, and yeah, it's pretty scary. I was like, no, 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 no. So be careful with that, because every your word can be used against you at that moment, and yeah, that's what can I say.
Thank you.
I hope I answered your question. Yeah? Okay.
We'll talk after that, please.
Hi, thanks for the presentation. I thought it was interesting that they had attention to detail, like making the screen shake, and they buried like the code, but then they used the same websites in like the really easy AI pictures. Do you have any sense why they seemed to be very good at the malware and then were kind of maybe lazy on the OSINT part, if you think that's fair to say?
Yeah, actually, that's the point my team leader at Moonlock used to say when I just came, and he would repeat it all the time. He was like, do not underestimate someone's failures or like stupidity or laziness, some kind of that. Sometimes we do mistakes just because, I don't know. And I would say that threat actors, they are not, they're pretty clever. And whenever we do a presentation or articles, etc., saying that, haha, it's funny, they're like, okay, and they learn out of it. So it's like cat and mouse game all the time. And it's like we go to work and we do mistakes and we learn out of it, yeah, that's the same path, yeah. Oh. So many questions. It's good, that means someone listened. I'm really happy.
Hi, thank you for the presentation. It was I love the theme. I have two questions, one a bit longer, one a bit shorter. When you mentioned you were pivoting on who is data, I know a lot of websites like redact that information by default. So is there any other clues you might use to maybe attach it to an identity? And my second question is, have you found any interesting clues or notes left by threat actors?
There are plenty of tools, and I think we need to do the training on OSINT. It seems to be an interesting topic for students. So yeah, I don't think we have time to tell about all of them. Of course, you have such things like, again, VirusTotal, Shodan, other like different open source sandboxes, etc., etc. And I had situations then I found something about even people when I did a human investigation. But the problem with it, if most of the time it's like some sort of PII, yes, it means like their personal information, and due to the law, you can't use it much here in Europe. Yes, you can't even investigate someone without letting know, like, for example, an HR or, you know, such stuff like that. So, yeah, you should be careful doing things. You should check first, like, law, and then do investigations carefully, I would say. That's my point, yeah.
And could I ask, have you found any interesting, like, ransom notes or notes left by anyone when you're analyzing malware?
I mean, once once I had a situation when I pivoted the person, and at some point I got the information that the person was escaping from the cops and kind of had an accident, and with the car went into like lake, and I was like, okay, let me somehow prove it or not. And I went to the like some sort of news channels, and I checked, and in reality 2 weeks ago, kind of nearby was such a situation, because it's kind of extraordinary situation. And you're like, oh my God, so that's how you found the geo, yes, the place where probably the person was a few weeks ago at least. And it's like, whoa.
That's super interesting. Thank you so much.
Yeah.
Awesome. Thank you again, Ksenia.
God.
Great talk.
Questions took more time than the talk.
Perfect. Great job. Oh, one more question.
What I wanted to ask was, so like their work kind of is sloppy, right? Like whoever did this, the threat actors. The whoever did this like attack, it kind of looks sloppy, right? Like the background work.
Yeah, it was a story. I mean, whenever I'm going into investigation, I always feel like it's not a movie, but the story, and I have to write it. I have to write it, and
actually, I meant it sloppy. So, like you told that it resembled.
Sloppy. Okay.
Yeah. It resembled one of the other nation-state threat actors, right? So it could be possible that some script kiddie might be wanting to mimic that kind of thing, and he might have made.
Oh, of course, script kiddies can do things. If you saw latest news, they kind of latest arrests from like hacking teams. There were guys 17 years old, kind of 18 years old, young people, and they start as like script kiddies, yeah. But I also got a message in my Twitter from someone who was like, you know, when I was 16 years old, I was working for ransomware gang, but now I want to do Mac security. Can you help me, please? And now I'm like 18 or something. I don't want to do any more like bad things. I'm like, what? that's yeah.
Yeah. So did you find any like traces to like any particular individual, because their work kind of looks sloppy when you analyze the binary, right? The further payloads like the Python scripts, any indicators that could trace back to an individual?
Like if they reuse the code or
yeah.
kind of course, yes. I mean, no one wants to deal with updates and features and etc. Yes, because like you and me, do we want have much more work when we have now? No. So that's why they're like reuse things, reuse infrastructure, reuse. Sometimes we can see when, for example, it was down for some domain, for example, was down for like few months, and then it's up again just because they reuse it from time to time. It's pretty common thing. Yes.
Yeah.
Yeah.
I'll catch you up with later.
Yep.
Thank you, Ksenia.
You can talk to me later during the break.
Perfect. For our final talk before lunch, we have one of the trainers, which is great because I heard a lot of great feedback. He's now going to give us a talk on one of his areas of expertise, specifically about the file system. And it's interesting because Greg has many CVEs. He's like the Apple security researcher file system guy. So, round of applause.
Thank you. Please allow me for a second to set this up. All right, I think this should be it. So, welcome to the talk. Why should you learn about the file system in 2026? It's a fairly niche topic if you attended the training. A lot of this has been already discussed, but mainly, my name is Gergi Kalman. I do Apple security bug bounty hunting full-time, and I do some pretty okay research sometimes. Sometimes I'm even proud of it. But mostly, I think this is fairly, easy stuff for like, I don't know, I don't consider it so cutting edge, but it's like ridiculously effective. So I think it's a fairly approachable thing to do. And that's been the theme of I've been getting questions about, not necessarily about my work, but how do I do this full time? Especially from, younger people. So I thought that giving a talk on this would be very beneficial. So my assumptions are that you're either a student or you're looking for a career change or you want to make a break into this thing. And if you're neither of those things, I'm sorry, this might not be as informational for you as I would like, but you will hopefully learn something. So why should you listen to this to begin with? Well, I was in your shoes. I started this almost 5 years ago. I was, well, quite frankly, a burned out programmer. I had enough of consulting work because that was not great. It paid well, but it wasn't, fun. And I managed to find a 0-day quite quickly, and then I kept doing this, and now I'm affectionately referred to as the file system guy, which is actually perfect, because most of this was not intentional. It just happened to be a very exciting thing that I stumbled upon. So I'm not saying that this career trajectory is realistic for you or any of those things, because each of us have our unique experiences and talents and interests. You might actually be much better than me in this given time frame because there's a lot of smart people in this room. So the point is, I've been a beginner. I've been where you are right now, and I think one of the biggest things, to me at least, maybe this is just me, but to me it was the lack of self-confidence that didn't allow me to start or try to do this earlier. And the younger you are, when you get rid of that, the better career and the better life you will have. At least that's my opinion. Looking back in retrospect, most of this was trivial, of course, because I had all the prerequisite experience that necessitated for me to go into this and to be successful. Whatever. But still, at the time, it didn't seem like even a realistic choice. So you might have heard about, these very classical sayings and stuff, and people do this, and people say these things, and usually it's well-intentioned advice, but generally this is outdated advice, and if I were a student, I don't want to scare you, but I would be horrified, because I don't think any of that works necessarily. At least it didn't work for me, but I'm a particular individual, as you might have seen if you attended the training. So if you're like a more normal person, I suppose that this is not exactly true in your case. However, getting a good job these days, especially if you have no experience and all that, it seems a very daunting task, and it seems to be difficult. And I think it actually is difficult. It doesn't just seem like it. And to make matters worse, right now our industry is going through a bit of a phase. I don't know if you have noticed this, but it's the transformation, they call it, and then people are getting fired left and right, and that job that might have looked awesome 5 or 10 years ago, you're just seeing these things. And I don't want to scare you. This is not about terror at all. It's just basically my Twitter feed of people. There's a lot of scary stuff going on, and we don't really know where our industry is going to go. And I don't think it's great right now. I don't think it's the end of the world, but it's a bit of a tumultuous environment right now. And it feels a little bit like fuzzing. I think this whole LLM thing is just going to calm down a little bit, because if it doesn't and it actually starts to think, then I'm going to give this talk and it's actually going to be scary. Right now, I don't think we're there yet, but it's a very interesting new time. So it's a little scary. It's a scary time. So if you don't know what to do, if you feel demotivated, if it feels like you can't win, if the world's against you, all that, you can always fall back on this one. You can always work for yourself. So what are those things? I know I'm not going to give you groundbreaking advice here, but if you learn objectively valuable skills, like objectively valuable skills, that will always be useful to you. Either just optimize yourself, your workflow, or the things, or how you think, how you pick targets, right? All of those things will serve you no matter where the industry is going to go and no matter where your career is going to go. If you have skills already, if you have research already, you can demonstrate those skills, and you should. Because you think it's not cool, you think it's, not something, but somebody else on the other side of the world, a person you never met and never heard of, might be looking for you, might be looking to connect with somebody who does or did exactly what you are doing right now. And even though you don't think it's impressive, to somebody else it might be. You can research your opportunities and figure out how the market works and why, and what incentives drives these things. Because a lot of the times what I noticed is that, yes, you can be a terrific technical genius, and you're still gonna get stuck. But if you understand like office politics and the life of a developer, you will understand more deeply what are the things and the surfaces that you should look. Because most of the times, the developers, they don't make big, grave mistakes because they're stupid. They make grave mistakes because they're rushed, because there's not enough time in the budget, because they're afraid to be fired, because they cannot take risks, or they won't take risks themselves, Those types of situations are very interesting to understand. And you can talk to people in your field, and you should talk to people in your field, people like here right now. Because I think there's no cheat codes in life, except for maybe one, and that's finding a mentor, finding somebody who you can look up to and whose work you like, or just somebody who can tell you that, hey, don't read 5 books, read this one and 1/2 of that. And that drastically cuts your time and makes you more efficient in getting to where you want to be. And at the end of the day, you need to make your own luck. And you need to do all these things, or should do all these things, but eventually you will. This comes with time, so I'm not giving you homework. So my concrete example was this. I knew hacking was an objectively valuable skill, and I wanted to do it because that's something I always wanted to do. But bug bounties, I'm old, so bug bounties back then weren't really available. So if you wanted to report something with good intentions, it would be very likely that you would be terrorized in a way that you would be threatened with a lawsuit, or you would be actually sued. Now, times have changed, thankfully, so bug bounty is a thing, and there are people who are making money off it, and there are some people who make a lot of money off it. Unfortunately, not one of those guys, but I get by it. So there are a lot more talent who does this, who are really, really good, and they share their write-up and their stuff online, and you can just look that up, right? Which is amazing. So what I ended up doing when I embarked on this journey is I tried to mechanize it, of like, hey, what are the incentives? What are the attack surfaces? What are the things that I should be doing? What are the things that I should be knowing to be able to do this successfully? And I researched a lot. I learned a lot from other people. I figured out what would be my personal skill set that I already have that I could leverage, okay? And some of you, at least in my training, came from the craziest backgrounds, the most unexpected backgrounds, and it's fantastic because you might have like a doctorate in something completely else and you think it's all wasted, but in reality, it's not. There's the strangest things that can overlap with this and with everything else. So don't think that was a waste of time. Basically, during this, I found the ASB, the Apple Security Bounty Program, and I was successful in getting my first bounty. That's a long story. I published about it. You can ask me about it later. It wasn't easy. But I have a lot of people to thank for that, who helped me as a beginner, and because of that, I feel like I owe this to all the other people, to give back, to show thanks and appreciation for all the people that have come before me. So if you're completely new, I figured we should introduce a couple terms, and those terms here would be bugs and vulnerabilities. We all know all software has bugs, and some of those bugs are vulnerabilities, i.e. they are security bugs, and a bug essentially becomes a vulnerability if it's exploitable, okay? So basically, vulnerabilities are exploitable bugs. That means an exploit is just the code that exploits a given vulnerability, i.e. it gets the attacker something useful. There's a special class of these bugs called 0 days. They're called 0 days because there has been 0 days since the disclosure of the bug, i.e. that's a fancy geekish way to say that the bug is unknown, the bug is private. Because the vendor doesn't know the bug exists and the users don't know that the bug exists, obviously it's going to be not patched. So this is very valuable if you would actually want to attack or hurt someone, and it is very valuable for a company because they would want to prevent their users from that hurt. And the good ones of these are powerful and pretty rare, maybe not so rare these days. But because of that, they're valuable and interesting, and finding them is very impressive if you're one of the persons who can find these things. Generally, you will be thought of as someone. That might not necessarily be the truth, but certainly it takes some sort of cleverness to be able to find this with any sort of consistency. So that's very good, especially if if you're looking for a job or if you're early in your career. Getting a couple high-value CVs under your belt is never a bad idea. So basically, this is the progression. I would advise you not to look for scary bugs in Google Images, because I shall remain scarred for life for that search query. So each 0 day is unique, of course, and not all of them are created equal. If you find a serious bug in a software nobody cares about, or a useless bug in a software that's popular and people care about it, you're going to be the squirrel on the left. You might get something out of it, but it's not going to be great. And you find a serious bug in popular software, you're going to be the squirrel on the right. By the way, Matthias helped me generate that image with AI yesterday because the other one sucked. I hope it's not too offensive for you. So essentially what you would be looking for is high impact, which is severity times user count, i.e. how I like to think about this is what can hurt the most people in sum the most. Not that I would want to hurt people, but if you have something that's dangerous and impacts everyone, people will pay attention to it and it will get fixed. The more damage you can do, the better. You can think about picking targets this way as well. So some companies even pay for these bugs, and that was a surprise to me because I've been getting these emails for like 20 years of like, hey, work from home and make money. Yeah, and now you actually can, which is funny. So yes, they will pay bounties, and this is good for everybody because this is good for the company's reputation, and this is good for the researcher because the more money you make this way and the more reputation you make this way, the more runway you will have to continue what you presumably like doing or you're interested in doing. Bad actors will also pay, but I'm not talking about that. So let me give you some unsolicited career advice. I think you might be wanting to consider working for the ASB or in the ASB because I think that's one of the programs that is fairly approachable. I think it's broad enough, and while Apple is a pain to deal with sometimes, they do pay and they do assign CVs and they do try their best. However, they are swimming in a bunch of AI slop and all that, and dealing with them is quite problematic in and of itself. But generally, I think this is one of the best programs. Microsoft's program is really not great, and Google has also been reducing scope, as far as I know. And I wouldn't go for the HackerOne or Bugcrowd things, because if the Twitter feed that I have is any indication, they are doing some really nasty stuff to researchers. But I might be wrong. I've never done web and stuff, so your mileage may vary. Oh, yeah, by the way, if you find a CVE in an Apple product, people will pay attention to that. So think like prospective employers and all that, especially if you're looking for offensive security or security-related jobs, this is going to be very important. So also being a bug hunter is pretty cool, because you get to be your own boss and you get to pick, hey, what do I want to do today, this week? This is not for everyone, by the way. You have to be, sort of self-motivated, which I'm not, and sort of persistent, which I'm not, and sort of smart, which I'm not, which is weird, but at least I'm attracted to these things, and that keeps me going. And even though you might not feel like you're particularly good at your job, or you're particularly competent, or you're particularly successful, once you make some leeway and some success, that will keep you going. At least that's how I work. But I think that is true for everyone. Being successful at something makes you like it more. As a side note, with this, you will quite literally, not just as a startup of saving the world, you will actually impact hundreds of millions, if not billions of people. A tiny bit. A tiny, 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 imperceptible, tiny, almost irrelevant tiny bit. But if you multiply that impact by 1 billion people, that is something that I can more easily wake up in the morning to do. And this might matter to you or not, depending on how you think about the world and how you think about yourself, but that to me is particularly important. And you also get to go to conferences and then just like shower people with your pseudo-wisdom about what they should do. That makes you think, doesn't it? So by the way, this is not a sponsored talk by Apple. They don't pay me for this, or yeah, I would be the worst spokesperson, so this is not actually an Apple advertisement. I'm telling you because this worked for me. I'm telling you because this is what I did, and I'm telling you because I like what I'm doing right now. Dealing with Apple, that part I don't like so much, but you know, they've been trying to get better, and hopefully they do. Regardless, I think if you if you would take this path, it would be useful to you in any case, because what this kind of research essentially is basically get good. You would get better. You would get better in your methods, you would get better in your tools, you would get better in your selections, you would get better in your thinking. It's practice, 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 practice. And the more you do something, the better you get at it. There's some counterexamples which I'm not going to tell you. Don't do drugs, kids. But as far as I can see, it's a zero-risk way to improve your own career and understanding of the world and software and protocols and certain things. So, you know, might as well look for bugs. But again, I don't want to force anything upon you. It's fun, at least for me, and it requires no permission and no job interview and no HR department. You can open your laptop, get cracking, okay? In full honesty, myself, I just like hacking stuff. If this pays my bills and I get to keep hacking stuff, I'm a happy man. I win capitalism. So again, very groundbreaking advice and just basically the game loop of a career. You're supposed to gain knowledge to get better results and solve more problems and get better rewards. Now, of course, this is not entirely true and crude and inaccurate, but translated to bug bounties, basically how this would go is you would spend your time to acquire skills, use those skills to acquire vulns, and you would report those vulns to acquire either bounties or CVs, or preferably both, and that would keep you going. Now, there's a lot of places where people get stuck. If you spend more time but your skills don't get better, that means you're working on lame stuff, or you're just doing dumb work that should be automated probably, or you're not looking at stuff that would truly push you. If you have better skills but you don't find more bugs, occasionally you just get unlucky, and that happens, or your target selection is bad and you're not quite there yet where you would have a chance of finding stuff. That's okay. That happens to everybody. It's very hard to gauge what to look for, especially if you're new here. If you find more bugs and you don't get more, sorry, I'm one slide behind. This is the slide I wanted to talk about. So if you have more bugs but you don't get bounties, that likely means that you are in a bad program or your reports suck. Or maybe that you think you have something better than you actually have. And screwing yourself over mentally like that is very, very easy, because we all wish we had something better. We all wish we found something bigger. But you have to be brutally honest and know exactly and accurately what you have, because that means that your report is going to be precise and accurate, and whenever that report is being discussed later and somebody tells you that this is not eligible, you will be extremely tough and firm, because you know what you have, and you know exactly why you have it and why it is a problem. If you do all this and you're successful and you're making bounties and CVs and all that, but you don't want to spend more time on this, it's very likely that you just get burnt out a little bit, and that happens to people, and that's normal, that's fine. So let's find some 0 days. So my personal focus has been logic bugs and file systems file operation stuff, because I think they're the future in a way, at least to me, because memory corruption has been mitigated everywhere, or it's getting mitigated more and more and more. And these are everywhere, and these are a fundamental building block of a secure system. So broadly mitigating these vulnerabilities is very hard, and the APIs and the entire understanding of this system is something that I think is being lost. I don't think people, especially young people, are looking into this thing because they assume that, hey, this is 40-year-old tech. Surely the people who came before me have figured this out, so there's nothing to see here, which is entirely incorrect. I think this is also beginner-friendly because there are some very set patterns and some very set vectors that you can use and leverage. You can start with soft targets, and you can start with well-known attacks. You can eventually graduate to harder targets, and the final boss, I think the final level, is you finding new vectors and new bug classes. So how hard are these? I keep reusing this slide for years now. This is POSIX, some of the foot guns in POSIX. This is what Apple put on top. So you can see there's a lot of attack surface here. In my blog and everywhere else, I documented this quite a bit. So basically, all operations are racy. Access control is very, very complex and unintuitive. Path resolution is more unintuitive. Users can mount. Advanced protections are basically regexes, and the attackers can deploy a lot of tricks. You can look each of these up. I don't want to waste your time right here because we just don't have it. Again, broadly, mitigation is impossible because everything you would want to do to mitigate this broadly would break the API, therefore break 40 years of expectations and all user space software, which is clearly not going to work very well. So in order to meet this prerequisite, you have to control one path component in most of these situations. Imagine you control the hello directory here, like you rewrite it with a symlink. Very easily or very trivially, this is going to be a bad news because the parents control the descendants. So eventually, you can make a root daemon write a file into a protected directory that you yourself couldn't. This is one of the most simple examples of one of these bugs. But these, I have found stuff like these in production Apple software not too long ago. So you can find these stuff. macOS, this is often a given because most of this protection is retrofitted, and we all know how that will go. Circumvention is fairly easy because Apple does introduce some mitigations, for example, launch constraints, but that wasn't introduced because of that, and that's also not entirely useful in this case. Apple, however, reduced the TCC payouts, which is hardly a mitigation, but a financial disincentivization, which I have a massive, massive problem with. I wrote an entire whiny blog post about it. Recently, you can read that if you would like. I hope they bring this back, but if they're not, that's going to be a little upsetting. There are some flags here that Apple introduced, which again pose the problem of compatibility. If you ever introduce these are Apple private flags, so you will not be able to push these upstream, thereby meaning that you will have to maintain that code. Good luck with that. So there's, by the way, resolve beneath one of these. I just jokingly bypassed in a Twitter post. Apple saw this, they thought I was wrong, and 2 days ago, they paid me for a bug where I actually used this in production to bypass one of their fixes, so who's laughing now? So this is retrofitting security. Doesn't work quite well, but it's a commendable effort. This is what SE Linux and AppArmor does. Unfortunately, we rely on these APIs for the past 40 years, and all software is written with this in mind. So any drastic change to that is very highly unlikely or difficult to do. So it is commendable. It's good that they're doing this, but it's going to take years and years and years and years until all of this is ironed out. So quickly, because I'm running out of time, my targets in 2026. Am I running out of time, Patrick, actually? Am I doing good? Okay, yeah. So the answer is yes. So my targets in 2026, there's a couple classic classes of bugs. I'm not saying everything I know about these because you would hear about it for hours. But just basically, if you're new, this is the stuff that you could find. TCC, we don't care anymore because Apple doesn't pay. Sorry, not sorry. That's the reality of the situation. We have bills to pay. So firstly, classic. POSIX LPE. The goal is to take control over a file that you couldn't take control as a regular user. That file is usually owned by root. Good examples of this are etc sudoers, the D, something under cups, There's a lot of possibility here, and this is a very widely researched area. The targets, of course, are going to be the processes that are running as root, and the example system calls that you would want to look for are chmod, rename, chown, open. There's a bunch of other stuff that you could, but these are the most plentiful and the most well-documented. And there's a very straight path of like, hey, I have this primitive, I have this target, this is the line I draw, that's it. There are many things to attack with LPs, particularly like targets that you would want to look at. If you have the primitive, the target that primitive would target, like a file or something, you could even invent your own, and those are very good. There's SIP bypasses, of course. These are the Apple-signed installer packages that require root to install. When you install these, system install D, which is the daemon that does this, will spawn a bunch of scripts that will do the post and pre-installation of these packages. Those scripts sometimes are vulnerable to injections, and every process and subprocess of system install D is going to inherit the SIP bypass privilege, yes? So like if you have a command injection in that, you can place malware or delete files that even root can't. Okay, very valuable. This is again like a 20K exploit. The other one is $22,000. This could be script command injection or just inducing some subprocess of a subprocess of a subprocess to do a dump file operation. The goal, again, is to manipulate the system in such a way that it ends up doing something that's useful to you. The third one is app sandbox escapes. Basically, the goal is to have a directory or a file created without the quarantine flag. Usually, you would look for XPC endpoints. When I say XPC, it's the Mac IPC. One of them, there's a bunch. Just think that any more privileged process that I can induce to do things, I could look at those attack surfaces. An example of this type of bug would be an XPC endpoint with an arbitrary directory create bug. That is enough to escape the application sandbox. I blogged about this. Basically, you create a directory that doesn't have this quarantine flag, and you fill it with symlinks because symlinks can't have it, and the final binary points to bin bash or something like that, and there you go. Because the operating system only checks for a top-level directory and the binary itself. Anything in between, it doesn't care about if it has a quarantine flag or not. iOS, yeah, I've been branching out into iOS, but I'm quite new, so made some partial progress. So let's say in theory, I have an arbitrary file write as root, and yeah, that's as far as I got. So if you have any tips, you know, my ears are always open. The attack surfaces in 2026, there's a lot of, I think most of the really good, really easy stuff is gone, especially now due to LLMs and all that, and a lot of people like jumping in here. But if you're just a little bit creative, I think you could still find some very low-hanging fruit. XPC, IPC, again, still incredibly promising. It's everywhere on the Mac. It's how the system is designed, and sometimes a lot of stuff is missed. And to be fair, to give credit where credit's due, LLMs are actually very good at reading code. Sometimes writing tests and all that stuff is they're actually useful. They can be useful. So where do you want to go from here? Read a lot. Follow other researchers. A bunch of people have been speaking out about complete chains, complete attack vectors that you can literally just plug and play into your particular vulnerability and you would get a root shell. It's not that hard. I think it's fairly approachable, but I might be very wrong. I personally published a lot about this, but Csaba Fitzel, Wojciech did, Mickey Jin did. There's a lot of big names who publish a lot of this stuff, and they're very easy to find. They're usually at OBTS. But again, publishing and learning is never enough. So I wish you happy hunting, and thank you for your attention.
Mahalo, Greg. We have time for one question before lunch. If there's more, Greg is very approachable, likes to talk nerdy about all the things. So, question number one.
Okay, is it working? Okay. So you were talking right at the end about how you can read other people's blogs and their attack vectors and take that and style it into your own bug bounty methods. But if they've already used it and published about it, wouldn't it be something that's already used? Or do you mean in a broader sense of thinking through their methodology of how they find the bugs and copying that in your own way in a different part of the software?
I specifically meant the situation where somebody doesn't think that a given bug is particularly valuable or gets them something interesting, and then at that point, your job is to figure out, is there a way where I can degrade the system's security in such a fashion that that would get me anything, or would get me deeper into the system, or open up more attack surfaces, or just straight up give a root shell. So a lot of these techniques are not exactly straightforward, but a lot of people have been saying that, hey, if you find like, not a file delete, but like a more minor, not directly, not well-known vector to exploitation, they publish it, you read it, and it immediately gives you ideas. So like, hey, I've seen like root daemons do this in a way that I can easily hijack it. I just didn't know that this was so exploitable that I just need to do 2 or 3 steps and I'm done. That's what I meant specifically.
Yeah,
Does that make sense?
So you're thinking about, so perhaps if someone got a 0-day, but then they mentioned, oh, they used a smaller bug before to get to that point, but they didn't.
Not necessarily. I'm talking about the path to exploitation, that you have a primitive that, let's say, you can move one file around, but it's fairly limited. But if somebody publishes about a bug that they had that's like this, you can see that what did they do to exploit it.
Oh, okay.
Does that make sense?
Yeah, that makes sense. Okay. Thank you.
Yeah.
Awesome. Round of applause for Greg.
Thank you.
All right, we now have a break for lunch, very similar to yesterday. It'll be at the same location. You should have all received your lunch vouchers. Lunch will go till 2 p.m., so that should give you some time to eat, hang out, talk story. Just make sure you're back here by 2 p.m., where we will continue with some intriguing iOS hacking talks. Enjoy. Okay. Okay, we'll also close this door so you could leave your bags and laptops here if you don't want to lug them around. So, thank you. Welcome back from lunch. I hope you had a good break. We're going to start the afternoon with a talk from Lucas, who's going to be talking about exploring coprocessor firmware. So let's give Lucas a round of applause and our undivided attention.
Okay, thanks. I'm Lucas, a PhD student at the TU Darmstadt, and today we will take an adventure beyond the realms of the iPhone's operating system and explore the firmware that runs on coprocessors of your phone. Coprocessors enable many great features. You can quickly share files with your friends, you can take a quick glance at the always-on display of your phone, or you can call for help in case of emergencies using the satellite connection enabled by your iPhone. And all of these features are enabled by coprocessors. AirDrop uses a combination of Wi-Fi, NFC, and also sometimes Bluetooth. Your iPhone also has an always-on processor that continuously runs in the background and provides you with the latest updates in a battery-preserving manner. And the satellite connection is actually implemented by the iPhone cellular modem. And they also are very crucial in terms of device security. Apple states in their platform security guide that they handle many critical system tasks, and they also implement some security features. So the firmware for some coprocessors is signed and verified upon flashing, and the actual code residing in the memory of your phone can also be modified. There's another security feature for this. But what if the firmware shipped by Apple for those coprocessors actually contains like some bugs, issues, or even vulnerabilities? This could impact the security of a device as a whole. That's why I would argue it's also interesting and crucial that we take a look at the coprocessors. There was also an interesting case. Svante already told you about Operation Triangulation. And as part of this exploit chain, the attackers used registers of the GPU, another coprocessor basically, to bypass all of the advanced memory mitigation features implemented in the CPU. So they were able to gain control of the system just by abusing an insecure coprocessor. And I'm really interested in looking into wireless coprocessors, because usually they implement protocol stacks that are very old, like decades old, and they are very complex with more features being added every year. So it's not that simple to implement them securely, and maybe they were implemented some while ago already. And Apple uses a special approach for their coprocessors in terms of vertical integration for the system. So they tightly integrate each coprocessor they build with other coprocessors and the main CPU to enable new features or to preserve battery. But then coprocessors also have access to many interfaces, which might be interesting for attackers. And for wireless coprocessors, we can grab a software-defined radio and simply send signals over the air to them to see if they might contain like some kind of vulnerabilities or to trigger some kind of crashes. And the baseband is yet another wireless coprocessor in your phone. It enables the cellular connectivity. So if you just want to access a website on the internet, usually your iPhone, everything you see runs on the application processor, the iOS operating system, and also all of those apps. But if you are now on the go and an app wants to query your website, it will go through the baseband processor, which handles all of the critical tasks for connecting to the cellular network. There are even more components underneath that actually transmit the signals, But for our use case, the baseband processor is the most interesting one to analyze. And it's getting more complex every year with additional features. For example, your iPhone can also connect to non-terrestrial base stations, so basically satellites that provide cellular connectivity. It also queries your device's exact location by receiving and understanding GNSS signals, so GPS, Galileo, and so on. And it supports those emergency features we talked about in the beginning, using global star satellites. And Apple devices have basebands from various companies. In the recent phones, we have basebands from Apple themselves, which is pretty new and interesting to analyze, and also basebands from MediaTek and Qualcomm. And those chips are not only in your iPhones, but also in your iPads and Apple Watches, for example. And exploitation of the baseband is also quite an interesting target. In the past years or in the past decades, it was always assumed that the security of the baseband was pretty bad in general, at least compared to the iPhone's application processor, where Apple is continuously introducing new features. And nonetheless, there's still a lot of critical data that passes through the baseband. So all of your packets, if you are using the cellular network, and also some internal state for connecting with the cellular network that could allow tracking of your location. Once you are able to exploit a baseband and potentially gain persistence, then it's quite difficult to notice this kind of persistence because we get only a few logs from the baseband itself. That's why it's not easy to detect. And it might be even possible to escalate from a exploited baseband towards the application processor. And this could be a future avenue as Apple continuously introduces more and more advanced features such as memory integrity enforcement for the application processor, making it harder and more expensive to exploit. So for basebands, we basically have cheap exploits, but we require skilled operators in the proximity of our target to actually send those packets over the air to our target phone. And this is not just a theoretical concept. There are many research papers, research talks, and so on, presenting baseband vulnerabilities, new methods to uncover them, and so on. Project Zero, a few years ago, also presented a vulnerability that could be exploited over the internet in the baseband, allowing for remote code execution. And again, there are also trainings for doing actual baseband exploitation. So it's not just a theoretical concept, but one that might actually be deployed in the field. And regarding the security mitigations in the baseband, there are also some, I would say, different opinions. Google said the baseband is pretty unprotected in general, while other specific companies said that vendors might have introduced new mitigations that make it harder to exploit the baseband in the past years, but they didn't talk about it. And that's our main motivation for taking a look into Apple's own C1 baseband that was just released last year. It's the first iteration of their homegrown project, I would say. And for this, we use 3 perspectives. We first take a look at the actual hardware of the baseband. Then we take a look at the integration into the iOS operating system. And finally, we analyze the firmware. For the hardware, the official specifications are quite slim, so we basically have a bit of marketing speech. Our C1 baseband is so efficient, that's great, and the C1X is even better, and that's basically it. And we got some technical specifications just saying, oh yeah, the baseband works in your country with your carrier, but not, again, any interesting details for us. Luckily, there were some details which we could use to build basically a model of the baseband, a hardware model, and everything starts with the baseband processor, which is the heart of it. It has its own dynamic random access memory and also static random access memory. And it is connected to a power management unit, to a radio chain that's actually delivering the signals over the air, and a GNSS stack, so it receives and understands GPS signals, and also like its own kind of storage. And for some components, we actually find their internal names in some shipping documents or so on. And we are able to see that like the power management unit was produced by TSMC and then shipped to India for assembly. And other third-party components provide us some data sheets, for example. And there are even more connections to the application processor, so we can actually send the IP packets we want to transmit over the air to our baseband, for example. We want to connect it to SIM card slots. And there are even some debug features which are visible in like those hardware specifications, but unfortunately they are not active on production devices, so we can't access them. And on the iOS side, we also are a bit limited because those interesting basebands for us are only in the iPhone 16e, and there are no exploits or full jailbreaks that would enable us to perform a kind of advanced reversing. We can only read system logs or create system diagnosis with some more files included. We can install Apple-provided debug profiles to get a bit of more data. We can read the packets between iOS and the baseband, or we can set up our software-defined radio to send custom packets towards the baseband and just see if it crashes or something like this. But we cannot use advanced system debuggers such as FRIDA or LLDB. Some of you might have gotten to know them in your training yesterday, and we can't also run arbitrary code or change any files on the system. But nonetheless, there's some interesting information within those system diagnoses we get from iOS. For example, the device tree, it shows how the iPhone's peripherals and additional components are connected to each other, and we also find their current state in those device tree files, and it basically confirms our hardware analysis, and we find that the actual interesting data, such as IP packets, are transmitted over PCI Express between the application processor and the baseband. But I would say the most interesting part is the firmware of the baseband. And luckily for us, it's unencrypted. We can just grab an iOS firmware image and extract a file, ftub.bin, with a custom Apple format. And with open source tools such as IPSW, we get some more files, which are the actual files being flashed onto the baseband. And actually, we got a lot of files here, but only a few contain executable code. For example, the ILLB file is the bootloader that initially starts everything on the baseband. The ACOS file is the biggest by size of the code files. It runs on an ARM v8 core and contains the operating system and also the cellular protocol stack. More files are for other cores that handle up and downlink data or implement the lower levels of the cellular protocol stack. And finally, there are some files with yet another architecture that implement receiving and potentially also transmitting some signals from satellites and to satellites. And with a bit of work, we can basically get it into our reversing environment, such as Binary Ninja. And to do this, or get like such a nice view, you usually have to do some tweaks, develop your own plugins or so on. So you have to make sure that the pointers resolve correctly. Usually there are also like a lot of function symbols you can see in here, such as file names or even function names, which you can extract and then apply to your code at a large scale. You can also find types in memory that continuously repeat and thus identify structures and again identify new methods or data that is actually contained within the firmware. And by doing this, we can extract a lot of information from the baseband firmware. So we get more data, how it interfaces with the hardware, how it works, how its operating system internally works, which tasks continuously run on the baseband. We also find more data, how it outputs diagnostics information, how it implements all of those cellular protocols, and finite state machines that basically keep a state when connecting to the cellular network. And in there, we actually find a lot of history because Apple bought the modem division from Intel 5 years ago. And a lot of code is actually similar to the old Intel basebands, which were in the iPhones in the past. And with those insights, we can analyze the security model of the C1 baseband and find that everything in the Apple world starts with a chain of trust. So basically, there's a hardware-baked boot ROM that verifies that the certificate of the bootloader, which is signed by Apple, is correct. And this bootloader then loads the various files for the baseband, such as the Arcos file with the operating system and the cellular protocol stack. And it ships a microkernel, which basically means a kernel that implements as little functionality as possible so that you can formally verify it. And this then starts a root task, which sets up even more security mitigations. And it can only communicate with the kernel using system calls. And this root task then starts 3 more tasks that also run in user space. And they are also called compartments. The platform compartment has a lot of access to the hardware because it manages the operating system and other hardware subsystems. The over-the-air compartment instead has no access to the hardware, or it's just quite limited, as it passes all of the packets you receive from the air. And if a packet should hit a vulnerable code section, then the attacker only controls the single user space process, and they communicate. So the processes communicate via remote procedure calls that, again, use system calls. So it's not that easy that you can simply change any kernel memory or so. And the middleware compartment communicates with iOS and also has some access to hardware, for example, for taking calls. And this is coined the operating system compartment kit, and it's basically a central security feature of Apple's baseband. And to generalize our findings, we also took a look at the security features of old Intel basebands. And there we can find that both the Intel and the Apple basebands share a common history, but the Apple baseband, its various cores and the firmware files implement more and more security features depending, I would say, on their target core and their target purpose. In general, you could imagine this as the baseband being kind of on par with an application processor that is also running on the iPhone. And remember, in the beginning, I said usually basebands are less secure than application processors. Now, thanks to those changes, we can roughly assume that it's a bit similar, but adapted to the cellular context. And that's basically it with my short introduction. If you have questions, let me know. Thank you. Okay, we have time for one question.
Thank you, Lucas.
Yes.
All right, for our next talk, we have Niels, who will be talking about the Apple Watch protocol stack. So let's give a round of applause for Niels.
Thanks. I like the shirts. Yeah.
Okay, cool. Hi, I'm very happy to be here. I want to tell you a story today about the Apple Watch. Or if we are a bit more precise, actually, I want to talk about systems and ecosystems. And of course, this being OBTS, I'm talking about the Apple ecosystem in particular. And you won't be surprised to hear that Apple is very vocal in their marketing about the privacy and security aspects of their devices. And there is something to that that's not just empty marketing. I don't want to suggest that. And I'm sure a lot of you have heard over the last day or today crazy stories about how difficult exploitation has been getting and how many new mitigations we have. So these real hardcore exploits are increasingly in the domain of highly specialized companies or nation states. And so people like me, people like myself have a problem because maybe we still want to do interesting stuff with iPhones. Maybe I still want to get some private data off of your phone, right? But I can't pull off these fancy exploits. So what we have to do is we have to get creative. We have to find another way into this ecosystem. And if we start thinking, what would we want from such another way in? Well, it would be kind of cool if there was some device that goes with you everywhere you go and that your iPhone implicitly trusts and shares a whole bunch of data with. And of course, that device is the Apple Watch. And if you use one, your iPhone and your Apple Watch kind of automatically, magically in the background share a huge amount of data. They share access to things like your health information, but also instant messages, iMessages, SMS, calendar events, device settings, emails, pictures, whatever. The list goes on and on. And so this, of course, to us is like a potential treasure trove of information that we might want to get our hands at. And so the core question that I want to ask today is, can we turn to an iPhone and say, hey, trust me, you know me, I'm an Apple Watch, give me all that data. Is that feasible? And in order to answer this question, the first thing we need is we need a really, really, really solid understanding of how all this magic even works in the first place. And that's where all the reverse engineering comes in. So if you were in my training yesterday, this will look somewhat more familiar than to the rest of you. But essentially, a good place to start is to start with what we know. And we know that these devices are somehow communicating via Bluetooth. And so this is a Frida hook, courtesy of Jiska, hooks into the Bluetooth daemon on iOS and just logs out all of the packets that are being sent and received. And that's a good starting point, because now we can connect our Apple Watch and actually see what's going on. Now, I don't think this looks like anything to you, but if you spend enough time staring at that, you can find some patterns. For example, we can notice that early on in the connection, there's a bunch of messages on a particular channel, this 3A channel, and those seem to share some sort of structure, type length value encoding or something. And if we click through enough decompiled source code, we'll eventually find the function that processes these packets. And in this case, we have a very simplified case statement here, where from the log strings that are being included, we can make some deductions of what these messages are actually doing. And so we can kind of slowly start to build an understanding of these protocols and the language that is being spoken here. And with that knowledge, we can go back to the Bluetooth capture that we have, and we can add support for the protocol that we just found. So now this already looks a little bit more readable. And we can basically just keep going like this and unpeel the layers of the onion of this protocol stack. Like here, for example, we can see once again like a type length value structure. We can once again dig through source code and find another handling function like this that now starts to include some references to protocols that will be familiar, right? We see something TCP, IP, ESP, some known familiar protocols, which is always reassuring. And if you keep doing that for long enough, eventually we'll end up at a pretty decent understanding of what this system looks like. And so in this case, it turns out that Apple does not fully trust the Bluetooth transport encryption between the watch and the phone, which is probably a good call, smart decision. So what they are doing is they are actually establishing a VPN tunnel between your watch and your phone. And within that tunnel, this IPsec tunnel, they are speaking mostly to Apple custom protocols that are called Alloy and Shoes. Shoes is used to provide internet access to your watch, which is not super interesting in our case, so we'll focus on the other one, we'll focus on Alloy. And Alloy essentially is where all of the interesting communication is happening. Alloy is a sort of message passing protocol, which means that if, say, your watch has made a new health measurement, like you burned X calories in the last 5 minutes, it's going to serialize that data somehow and say, OK, the phone needs to know about this. And it will send an Alloy message to the phone, and that message is going to carry a topic identifier. And on the receiving side, once we sent it over the air over like this IPsec tunnel and so on and so forth, the identity service daemon on the phone is going to receive that. It's going to look at the topic string and go like, OK, this looks like something that the health daemon might be interested in. And so then it's locally on the phone forwarded to the health daemon, and that can then do the actual application-specific processing of that message and maybe send a reply back if there's anything that needs to happen. Now, if you paid close attention to this diagram, you'll notice there's a conspicuous gap. That's because there's actually a secret third protocol. Because not only does Apple not trust the Bluetooth encryption, they don't really trust the VPN encryption either, it seems. So for particularly sensitive data, for health data, they actually homebrewed their own additional encryption layer, which is a bit sketchy in parts, but we're not going to get into that today. What we are more interested in is the question from the start. How does this work with trust and establishing trust? Because when you start pairing an Apple Watch to a phone, there's no pre-existing relationship. These devices have never spoken to each other. The watch doesn't even have an internet connection at the time. So how do you establish trust there? And well, it turns out that that's basically done in very much the same way as any other Bluetooth peripheral. So if you pair your phone to a car or something, right, you know the drill, how that goes. You have to enter like a 6-digit PIN or something to confirm the connection. This works in very much the same way. And when I was analyzing this, I was always expecting to hit like a brick wall of Apple-specific magic where they do some fancy device attestation or something to make sure that you're actually talking to a real, genuine Apple Watch. And that wall just somehow never came. So it seems like there's nothing inherently magic in this pairing. And so the attack that we were considering from the start still seems kind of feasible if we invest the time and the effort to actually not only understand all of these protocols, but also re-implement them to a degree that our implementation works with an actual iPhone. So we have this very arcane, very complex, highly custom protocol stack that we kind of barely understand. But if we kind of dig in deep enough and really understand all these protocols and how they work together, well, we can build a very cursed setup that looks something like this. We can have a Bluetooth-capable microcontroller that handles the low-level Bluetooth stuff, that then hands over packets to our computer, that then hands off the packets to an Android emulator, that then has a ton of custom cursed code that re-implements these protocols to exactly the degree that we need to make it work and no further. That took a long time. It's also a very fun project. I can recommend it. You learn a lot. And eventually, you might get to a point where you've re-implemented the entire thing, and your weird, custom, fake Apple Watch can actually talk to a real iPhone. And you see a kind of blurred transcript of that conversation here. And if you keep playing along in this pairing game and you keep sending back the correct replies for about 350 messages or so, your iPhone is actually going to send us your Wi-Fi password, which is fun and probably not the best thing. And now with this re-implementation, we are also in a very fun position where you can just play with this a bit, see what we can do, see what fun things we might get up to, what evil things we might get up to. And of course, that's a bit sketchy, and we might want to make sure that we do this in an ethical way. So what we can do is we can actually change the terms and conditions that are being displayed as you pair the Apple Watch and change that to include something like, we will be stealing all of your data, including but not limited to Apple ID credentials, Wi-Fi credentials, unique device identifiers, and health data. So this is completely above board because we informed the user. That's fine. Don't worry about it. And then, well, we can move through the pairing and we can see what kind of data we can extract, what kind of private information is leaked there. Here is an overview of the POC after like a typical run. And a very fun thing that we can also do is after we move through this watch pairing process, we can actually start doing anything that a legitimate Apple Watch might be able to do. And that includes opening the camera on your iPhone, taking a picture, and having that picture sent back to us. So we can actually kind of remotely operate your iPhone's camera after pairing to a fake watch, which is very fun when you finally get it working. And I have a very condensed speedrun video of that for you here, where you see our re-implementation, the information that we are extracting, and here you can see me moving through the pairing process kind of very, very quickly. And then once we are completely paired, the POC is just going to open the camera and remotely trigger a photo. So we, of course, disclosed this to Apple. I hear that they are working on a fix, and it's going to be available sometime soon. If you're interested in this entire topic area, there's a little bit of further reading for you. I have published a paper that doesn't cover this attack vector in too much detail, but you can learn a lot about the Apple Watch protocols in there if you're interested, and a lot of that is also already open source and available on my GitHub if you want to play around with that and then maybe find another cool way to do fun things there. And then one more thing before I am done with the presentation, because in the course of this research, I stared a lot at different protocols, different data formats, different serialization, unknown serialization formats, and trying to make sense of them, trying to add support for them. And I think many of you, if you want to go into this field, sooner or later you're going to be in a similar situation where you try to make sense of some data that's being sent over the wire. And I took all of the parsing code that I wrote for this project, and I turned it into a web app that's called ByteWitch. Some of you will already have seen that in my training yesterday. But I think it turned out to be a very cool project and a useful tool. It does decoding in your web browser, live, instantaneous, without any installations, for a lot of custom and weird Apple formats as well, like BP lists, OPAC, stuff like this. So if you ever encounter a weird blob, this is my advertisement block to tell you to paste it into ByteWitch. And it's also open source, of course, so if you find something else that is not supported yet, feel free to add it in there, and maybe we can all learn and profit from that. That's it from me for today. Thank you so much for listening.
Thank you so much. That was a really, I mean, all the presentations have been incredible. Was that a zero touch? Like when that setup goes on, you showed the demo, you're emulating an iPhone, but I'm wondering, yeah, what's the user interaction on both sides required?
Yeah, that's a really good question. It's not anything close to zero click. that severely also limits the security impact of this vulnerability. I don't want to overstate that, because you actually have to trick the user into scanning like a fake pairing code. And then once you scan that code, you get some level of access. And then once the user actually completes the pairing, you get another level of access that includes the camera thing. But you can get pretty convincing looking fake Apple Watches off of AliExpress for like $20 or something. So I think it's still a reasonable threat model. Some of my paper reviewers seem to disagree on that, but that's life, I suppose. Yeah.
Hey, Niels. Just a quick question. Apple makes a bit of magic in the sense that they have this funny-looking animation they're also using in different other stuff. I think Apple TV, a couple of other things. Does this do anything, or is this really just a magic?
Yeah, we also looked into that. At some point, I had my watch under a microscope trying to figure out what's going on in the code. There are some patents out there from Apple where you can kind of get an intuition of what's happening. You can think of it as, like the video in the background is completely fake, doesn't matter. There's an invisible overlay that you can think of kind of as like two alternating versions of a QR code that are kind of designed to cancel out to the human eye. So you don't see the overlay, but the iPhone camera can pick up on it. But we don't really understand how the encoding works in detail, because it's not just a simple QR code. But it turns out that you can hook into Apple's implementation of it and use that to encode and decode these codes and look at what's in them. And there's also some GitHub repos, one of them from us, but we are also building on previous work that you can find online. Yeah.
Awesome. Thanks, Niels. Round of applause.
Thank you.
For our next speaker, they have requested no photos, please, so please respect that. So now we will have Sebastian, who will be talking about emulating a new iPhone. Round of applause.
Okay, got it. Okay, so hi everyone, happy to be here. I'm Sebastian, and I reverse engineered iOS Quick Start feature for my master's thesis, and I want to outline my process for doing so, for looking into Apple's wireless protocol stack, and give a short overview of what I found out. Yeah, let's start. Why would I do this? So Quick Start is the feature that allows you to migrate your data from an existing iOS device to a new device, so an iPhone or an iPad. It takes a few minutes and it transfers all kinds of data. So that includes Wi-Fi credentials, passcode, Apple ID, eSIM, photos, videos. So lots of quite sensitive data, and that is quite an attractive target for attackers. So I want to understand, how does it work? Is it secure? And could we maybe re-implement this feature and run it on a non-Apple device? Yeah. So how did I go about this? The first thing I used were syslogs. They allow you to observe functionality from the outside. Lucas already talked about this. You can use debug profiles, which enable more verbose logging. I used those as well. And they allow you to create packet captures of the Bluetooth and network communications. So you can load these packet captures into Wireshark, and Wireshark proves very useful for analyzing standard protocols, but you can also write extensions which then allow you to parse custom protocols as well. We can also look on the inside by extracting binaries and from either a jailbroken iPhone or an iOS firmware archive and look into those. We can put them in a decompiler, for example, Ghidra, IDA, and so on, and then look at the decompiled code and try to figure out what's going on. Decompiling, however, gets you only this far. At some point, it's quite useful to do some dynamic reversing as well. So you've heard about Frida before. It allows you basically to hook into function calls and dump data that's currently in memory. And that allowed me to hook into encryption functions, dump encryption keys, and basically decrypt the data as well. Okay, so now that we have the process, what could I find out? I want to give a quick overview of the whole process and what's going on internally. So quite early during setup, the new iPhone will broadcast a specific payload via BLE. That's what you can see up there, and nearby iPhones will pick that up and then display this pop-up, set up your new iPhone. Once the user clicks continue down there, the iPhone will connect to the new iPhone via BLE, and Apple uses a proprietary protocol to negotiate a communication channel. Then we perform a pairing to authenticate the connection. So we've had this come up in the previous question. Apple also uses this visual pairing code here, which is scanned by the old iPhone, and that is actually just transmitting a 6-digit numeric code. You can also use it manually, and then the new iPhone will directly display the code. The protocol that is used for pairing, Apple calls it pair setup. It is an implementation of the secure mode password protocol. That is a password authenticated key exchange protocol. To put it shortly, you can kind of imagine it like a Diffie-Hellman key exchange, but it will only succeed if both sides know the pairing code. So this ensures that the old iPhone is actually pairing to the correct device. The result of this exchange is a shared secret that is used to derive encryption keys, and then all further communication is encrypted using ChaCha20 Poly 1305. That's an authenticated encryption cipher. Yeah, now that we have an encrypted communication channel, the actual application payloads are encoded also with some custom Apple encoding that is called OPAC. It is basically a data serialization format that works similar to JSON, but you have a binary encoding that is quite efficient in the end. These messages have a common structure. They're either requests or responses. And the new iPhone can request certain data from the old iPhone. For example, Wi-Fi credentials are also transferred quite early. Device information, then there's a request for passcode validation, and requests that allow you to get Apple ID tokens and NSZ data from the old iPhone. And that is used for passwordless Apple ID login. As soon as the BLE communication is done, we switch over to AWDL. That is Apple's peer-to-peer wireless technology that is also used in AirDrop. It is based on 802.11 frames. AWDL uses a standard MDNS-based service discovery mechanism for advertising an IPv6 address and a TCP port to which the old iPhone then connects for further communication. And again, the first thing that is done is another pairing mechanism. This one is called pair verify, and it is non-interactive. It uses a pair of elliptic curve keys that were negotiated during the BLE connection to verify that they are still talking to the same device. So we cannot simply have another iPhone in AWDL that is then acting as a new iPhone and receives all the data. The pair verify protocol uses an elliptic curve Diffie-Hellman exchange to create a secret channel and then it uses signatures to verify that they are still talking to the same device. This again results in a shared secret that is used to derive encryption keys. So we again have encrypted communication over this TCP channel. Now we move to the main part, which is the actual data transfer. As it turns out, the iPhone simply transmits an iOS backup over this channel. This is the most data-intensive task, and that's why AWDL is a good match, because it provides data rates comparable to Wi-Fi. The actual file messages are also encoded in multiple Apple-specific ways, and we have some compression going on as well to ensure that this is efficient. And the new iPhone will just acknowledge these files, and at some point when everything is transmitted, it will just say, okay, we're done. And then the old iPhone will display a message, do you want to reset this iPhone? Or do you want to keep using, or maybe trade it in? So this is basically the end of Quick Start. So what do we actually get in this backup? Of course, photos, videos, documents, app data, but also quite interestingly, the iOS keychain. It also gives us the necessary means, so a keyback and a password to decrypt this keychain, at least partly. And that will give us access to sensitive items such as website passwords that you saved in Safari, for example, all kinds of Wi-Fi credentials, and also Find My Keys, which you could use to track the user's devices. I compared this to a regular backup, and it is pretty much equivalent to an encrypted backup you could do via a cable. Okay, now that we know how Quick Start works, can we actually re-implement it on a different device? And turns out, yes, we can. I use Python to write a CLI re-implementation of Quick Start, which actually just runs on my laptop. It implements the BLE and AWDL communication from the perspective of the new iPhone. I think that's the more interesting part because we don't have to send that much data and we get a lot of data back. Yeah, let's see if the recorded demo works. So we can see here the BLE advertisement caused this pop-up. As soon as we click connect, the BLE communication starts. And this is where we request the device information, Wi-Fi credentials, Apple ID tokens, all of that. But first, we do the pairing exchange. In this case, I hard-coded a pairing code of 1, 2, 3, 4, 5, 6. Yeah, this is the part where we do the actual encrypted BLE communication. This takes a bit since the messages are a bit longer. And now we've already switched over to the AWDL communication. We also do the second pairing exchange, and now we start receiving files. So you probably can't read it, but down there we've already received the keychain export, and then we'll receive all sorts of other files. They'll start scrolling across the screen in just a moment. Yeah, this is an iPhone with not much data, so it will finish quite fast. Yeah, after that, we can just click continue, and we'll be prompted to erase the iPhone. And yeah, that's basically it. Let's also take a short look at security. So with this re-implementation, of course, it's quite easy if you have temporary access to someone else's iPhone to get quite a lot of data off this iPhone, maybe without them noticing because it's wireless. This used to be possible for iOS version 16 and lower. Since iOS 17, because Apple has probably become aware of this, they have implemented a re-authentication measure. So you have to re-authenticate either with passcode, Face ID, Touch ID, before you can even click this continue button. So it will basically initiate no Bluetooth connection before you do that. The pairing mechanisms, as we've seen, are quite effective at mitigating machine-in-the-middle attacks. So even if you were to take over the BLE or AWDL connection, you would have to know the pairing code to actually succeed with this pairing exchange. And in that case, well, if you already see the pairing code of someone else in your proximity during the setup, then you might as well just take their phone away. So that is quite a strong attacker model, which yeah, makes the process a bit trivial. Finally, I also didn't encounter any countermeasures for verifying the hardware platform, so no MFI stuff going on there. That's what actually enabled the re-implementation in the first place. Yeah. Now to give a bit of an outlook on interoperability. The EU has introduced the DMA legislation, which forces Google and Apple to build interoperable device migration features. And they have actually delivered that while I was still writing my thesis. The iOS 26 has it right now, and I think Android 17 also has it since a few weeks. I also looked into how that works, and it turns out it's a completely different protocol stack. So they used a lot more standards-based protocols like 6LoWPAN, HTTP, TLS, and a custom TLS extension. And you can very clearly see Apple's fingerprint in these protocols as well, because they also use password-authenticated key exchange protocols to authenticate the connection between both devices. And it turns out Apple repeated their own mistake and again forgot to add re-authentication in an early iOS beta. But when I reported it, they had already fixed it, so no bug bounty. Yeah, but as you can see, this interoperable feature kind of makes my re-implementation at least useless for interoperability reasons. I still think it's nice to kind of have more better access to your own data and maybe to poke around a little if there's anything else to find in there. I've also open sourced my re-implementation 2 hours ago, so you can find it under this QR code. I also put a link in the slides if you want to use it later. Yeah, that's it from my side. Thanks for listening.
Okay, we have time for one question.
If I understand correctly, the entire security of the process, the cryptographic security, is derived from the initial setup based on the pairing code, which, as we saw, was like 6 digits, I think. Did you look into, because that's not a lot of entropy in that 6-digit code, did you look into whether that could be brute forced without requiring repeated user interaction?
Yeah, that's kind of the whole idea behind the secure remote password protocol. That it requires some sort of interaction to actually know whether your pairing attempt was successful or not. So you would have to, for every retry, basically go through the first 3 messages, and then you'd know whether you're correct. And that, well, so it's not really vulnerable against dictionary attacks, and this is, at some point you will run into rate limiting, and it won't work. So that's what makes this so effective.
Thank you, Sebastian. All right, for the final talk of today, we have Billy, who is going to be talking about getting started in iOS security, which I think is a very relevant topic for many of us here. So, round of applause for Billy.
Is it set? Okay, well, thanks for being here, everyone. So while thinking of a topic to actually present today, I came up with a few different ideas that would be good kind of introductory level concepts for getting started with iOS research. And in the end, I merged a few ideas into one talk. So this should be ideally a pretty good quick start guide for anyone who's interested in deep system research on iOS, vulnerability analysis, exploit development. So we're going to cover a lot of theory and also some hands-on stuff on how to set up your own research environment, and then a practical example that you can kind of follow along with at the very end. So first of all, about me, I've been doing iOS research for about 10 years as a hobby, and for the last 6 years professionally, doing vulnerability research and exploit development, mostly in the kernel and in sandbox escape areas. I also have a YouTube channel, which some of you may be familiar with, where I basically cover in-depth breakdowns of complex exploits that have been found in the wild, reverse engineering topics, and stuff like that. So check that out if you're interested in like deeper technical stuff. And so the way we're going to structure this today, we're going to look at the landscape in iOS security as a whole, both the way Apple structures their security model and how the attacker would approach this. Then we'll look at how you should set up your research environment for doing iOS research in the modern day, 2026. And then, as I said, a hands-on example of patch diffing your first bug. So where do we begin? The iOS security model, I'm assuming a lot of people here probably know the general thing here, which is iOS consists of these 3 main pillars of security. So everything begins with a secure boot chain, where then we have code sign-in and we have sandboxing. These have been around since, I think, even the early days of iOS. So whenever you power on your phone, the boot ROM is the first piece of code that's going to run, and it's going to use the public key that's baked into the hardware to basically kickstart this chain of trust to verify the signature of each bootloader component all the way up to the kernel to ensure that this came from Apple. So as an iPhone user, you can be pretty secure in the fact knowing that the firmware that you're running is from Apple and hasn't been tampered with. If you were able to tamper with it in some way, you would fail upon booting, and you'd either hit a boot loop or you'd find your device in recovery mode and be forced to restore it. The only exception to get around this would be using a boot ROM exploit, which are very rare. So with the secure boot booted, you're then forced to be under the rules of Apple's code sign-in and sandboxing. So in user space, everything you try to run needs to be validly signed by Apple. So any app you install, any binary you want to run, it's going to be checked at the kernel level that it has a valid signature. And this, of course, will help prevent tampering and stuff like that. It's enforced in the kernel, and it's also enforced with hardware-backed additions to kernel security, with the more recent additions of the TXM and the SPTM, which are actually going to be out of scope for this talk, but These are basically conceptually like a kernel within the kernel that's more privileged than the kernel itself. So for some sensitive operations involving page tables and code sign-in, the kernel will need to call into these routines to deal with that. So this has only been around for the last few years. And again, the point of code sign-in is to prevent code tampering. So if someone modifies even one instruction in a binary you have, that app is going to be killed. And it also facilitates entitlements, which ties in closely with sandboxing. This is a way to give your app or process special abilities on the system. And these entitlements are tied in with the code signature, so you cannot just modify these entitlements. And then, of course, sandboxing, much more common. We see this on most operating systems. It's a way to restrict which processes get access to which attack surface to the wider system. And anything that's considered risky will be hidden away from the app, and instead you would be required to go through like a proxy process to access certain kernel drivers or risky surface. So to visualize that, if you have an app on this side, you can see that rather than giving the app access to all of these kernel extensions directly, we isolate the app in its own container sandbox, and we give it very fine-grained control over things that we want to allow it to see. So in the case of the Apple Neural Engine, we have a user space component known as the ANED, which is the Apple Neural Engine daemon. And as a normal app, you're allowed to communicate with this system process, and that process will make requests onto the actual neural engine driver in the kernel. And this, of course, prevents you from being able to have as much control over messing around with the kernel API that will make it much, much easier to exploit. Sandboxing, again, is implemented in the kernel via macf hooks, which are basically short functions that get added to common handlers for functionality. So, for example, the kernel syscall handler, as soon as you enter a syscall, the kernel is going to branch out to this short hook. It's going to do some validation over who the call-in process is, and it's going to read your sandbox profile to check if you're allowed to perform this action or not. So sandbox profiles are written in this language here. This is a snippet from a random sandbox profile. You can see it basically will allow or deny specific actions. So in this case, this one would allow you to communicate with these three kernel drivers. And by default, everything is denied. So you have to whitelist the operations you want. So aside from those three main kind of pillars of iOS security, in the last few years, we've seen a lot more modern mitigations that are based on Apple-specific hardware. So the TXM and the SPTM, as I mentioned, and also things like the KTRR, which prevents you from modifying kernel code after the kernel's been booted. But again, we're not really going to discuss that in this talk. So let's look at the attacker's perspective and how you'd go about breaking through all of this. So in this context, the attacker that we're talking about is an attacker who wants to deploy an exploit chain against a phone. So we're talking about kind of a full chain, one-click or zero-click remote exploit of an iPhone. And the aim here is to exploit bugs in system components and connect these together in order to break through all of the security features with the end goal of running privileged code on the phone. And here is a kind of simplified diagram that illustrates the main components you typically see in an exploit chain. So we have three distinct kind of categories here. We have the stage one, which is going to be the remote code execution stage. Then we have the sandbox escape stage, which may or may not be needed. And then the LPE stage, or the kernel exploit. Once you have all of that, you should theoretically be able to run like an implant binary or unsigned code. So let's look at these in a little bit more detail. So first of all, remote code execution. So this is the entry point for the exploit. This is how the attacker is going to make initial contact with your device, and it's how they're going to get their code running. They're going to get their foot in the door and kickstart the rest of the chain. So the attack surface that we typically see for this kind of thing is, of course, browser memory corruption, so WebKit on iOS, media parsing corruptions, which can apply to both the browser and messaging apps, and then anything that's basically reachable from the outside world. So this could include Bluetooth, AirDrop. There's been some research on this in the past. More commonly, though, we do see just browser and messaging apps, mostly. So let's look at these in a bit more detail. And also, I decided to include third-party apps. Now, this is kind of a substitute for a remote code execution exploit if you're talking about it in the context of jailbreaking, because with jailbreaking, you're essentially running an exploit chain on your phone, but voluntarily with the phone that you own. So you're kind of skipping this RCE stage, and you're installing an app deliberately that contains the next stage exploit. So it's kind of not an RCE, but I thought it was worth including this for the people who are interested in jailbreaking. But let's look more at how browser exploits would work. So for browser exploits, we'd be looking at doing memory corruption in the browser engine process itself. So ideally to build primitives and get memory read and write within that browser process. So if you think about a browser engine, you would have the engine process itself, which is a native process running that's handling your JavaScript execution environment. And it creates the illusion of the JavaScript execution environment, which sits on top of it. So it's the interpreter, the JIT compiler, all of that stuff. So when people try to exploit browser bugs on iOS or macOS, or any platform actually, you typically are trying to run some unusual JavaScript code in the JavaScript environment in such a way that it's going to confuse, so this is an old JIT bug from like 2019, but this code is going to do something a bit unusual that the interpreter has not accounted for, and it's going to confuse the state of the actual like engine program that's running this JavaScript code. And depending on how you confuse that state, you can end up with corrupted objects in the native process that are representing your JavaScript objects in your JavaScript execution environment, which can allow you to do all kinds of weird things like start to read out-of-bounds memory from the actual native process into your JavaScript to then continue using and build an exploit upon. So this is a picture from an exploit I was toying around with. This is the 2019 bug, the JIT bug. But you can see here I've got a simple web page opened, and there is a real iOS kernel pointer, iOS userland pointer rather, on the screen. And obviously with JavaScript, you don't deal with pointers. This is through the use of an exploit and then building a primitive that's allowing us to read out-of-bounds values that are coming actually from the renderer process itself. So you have pointer leaks through this. You can then build other primitives to do out-of-bounds writes, and you can manipulate all of the underlying structures that are represented in your JavaScript. Once you have read and write in the browser, one unique characteristic that browsers have is, of course, they use JIT for their JavaScript optimization. And this has a unique attractiveness to attackers because the browser process is allowed to have pages of memory that can be used for JIT, in which case they need to be able to write instructions to that memory and then execute it, which gives it the unique characteristic of being essentially read, write, execute, something that other processes are not allowed to do on iOS. So if you attack a browser process and you can manage to load your own shellcode into a read, write, execute page, your second stage exploit is a whole lot easier to execute because it's just a precompiled thing. Whereas other contexts, you're probably looking at using return-oriented programming or something a lot more tedious. So let's now look at messaging app exploits, which are the other main target for remote code execution bugs. So these typically can be either 0-click or 1-click, depends on the exact bug. And they're typically parsing issues in media formats or anything that can really be sent as an attachment to a message. So images, videos, audio, PDF, fonts, even more niche things like Apple proprietary things, like we've seen the PK pass format for the Apple Wallet being abused in the wild chain. Anything that's received as incoming data to your messaging app is going to be parsed and could be vulnerable to memory corruption issues. And the reason this can be used for 0-click is because obviously when you actually receive an image via a messaging app, depending on your configuration, the phone is actually going to render a small thumbnail of that image in the banner. So obviously that image file that was sent has already undergone some parsing logic without the user having to actually click on anything. So if that parsing logic was enough to trigger some kind of bug, then you're already at risk of being hacked, basically. Some in the wild examples, obviously the famous NSO forced entry bug exploited a bug in a JBig2 format. Very complicated exploit. Project Zero has a nice blog you can read on that. Then a couple years after that, the WebP bug was used in conjunction with the PK pass vulnerability. I actually did a separate video where I actually analyzed the entire kind of exploit strategy from the binary exploitation part of this on YouTube. So if you want to see the actual technical details of that, have a look at that video. And even more recently, we've seen WhatsApp 0-click bugs exploiting parsing issues with the DNG format. So that is the remote code execution stuff kind of out of the way, just a high-level overview. Next, let's look at sandbox escapes. So once you've got your remote code execution, let's assume it's either in the browser or it's in a messaging app, you're likely going to find yourself in a pretty limited sandbox environment because Apple knows that these processes are highly targeted, and so they deliberately lock down these processes with pretty restrictive sandbox profiles. And you don't really have much access to the wider system, and so if you want to hit the kernel, in a lot of cases, you're going to need a sandbox escape. It's not always required, however, so it does depend on the bug you're looking at getting into the kernel. So for example, the Pegasus chain, the really old one from 2015, this chain actually did not need a sandbox escape because the kernel bug that they were reaching was directly accessible from the web content sandbox profile. The bug was in a very commonly used part of the IOKit codebase, the OS unserialized binary function. And this was therefore reachable in many contexts. And so for this Pegasus chain, they actually, once they had execution in the browser, they could hit the kernel directly without the need for a separate sandbox escape vulnerability. Same kind of thing for operation triangulation. Now, even though there's a bunch more components here, if we just look at this part here, the Safari exploit was also able to get straight to the kernel exploit without a sandbox escape because that kernel exploit was also triggered through a muck system call that was very commonly used by many processes. It was to do with the virtual memory handling of processes. Yeah, so that went straight to the kernel VM bug. So in the case that you do need a sandbox escape, however, the way this would actually work is you would look for a different target in user space before going for the kernel. You'd look for something that has interesting kernel attack surface that you would like to leverage. So let's say that you are a hacker and you're inside the browser. You've done your browser exploitation component, and now you're running code on behalf of the renderer process. And you're wondering, how can you reach the kernel? You look at your own sandbox profile, and you see that you are denied any IOKit access, which is the kernel driver interfaces. And to keep it simple, let's just assume that that kind of cuts off most of your access to the kernel. But you are allowed access to one userland process, process A. And if you then see that process A, he has his own sandbox profile, which does allow IOKit access to one kernel driver class, class B. So what you would do is you would attack process A first. So you'd find another bug that you can reach over IPC from the browser to process A. You'd exploit some memory corruption, maybe execute a drop chain inside of this process, and you're now basically going to upgrade your context. So you've kind of hopped into process A, meaning you can now access whatever process A's sandbox profile permits. And so from there, you would then be able to reach that bug in the kernel driver that process A was able to access. And then finally, onto the kernel exploit itself. So obviously, this is kind of the end part of an exploit chain. The aim is to get kernel memory read and write, which typically has been known to give you kind of full control over the device. It's been known as the kind of end goal, although realistically, as I keep mentioning, SPTM, which is the secure page table monitor, and the TXM, trusted execution monitor, these are additional layers that you'd actually do need to get through if you want to run completely unsigned apps. So this will block you even with kernel read and write. But kernel read-write is still a great goal that most people consider a pretty good success, at least for proof of concepts. And for the kernel, the types of attack surface you'd be looking at would be either syscalls in the BSD side of the kernel, so these are your networking kind of stuff, file access. Then we have the muck side of the kernel, which deals with the virtual memory management and IPC ports and stuff like that. Or the kernel extensions themselves. There's a bunch of different drivers that are available in iOS that been historically known for many bugs. So yeah, that is kind of an overview of the main components involved in an exploit chain. As I said, it's very simplified, and in reality, you're obviously dealing with extra mitigations at every stage. So pointer authentication affects every component, so you're going to need a separate kind of bypass for that, and in some cases, those bypasses feel like exploits of their own. If you're on an iPhone 17, you're going to have memory integrity enforcement, which is going to really affect and limit the types of bugs that you're able to use for these components. And again, at the end, TXM and SPTM after your kernel exploit. So that's a good amount of theory out of the way, I think, to give an overview for iOS exploitation. So where would you actually begin if you wanted to start out doing iOS research and getting hands-on with some of these bugs, reverse engineering exploits, just playing around with this kind of stuff? So you're going to need your own iOS research setup, which is going to consist of hardware, which will be your devices to work with, and of course, software tools that you can use to help with your research. So for your test devices, you basically have three main options. The options are pretty good these days. Of course, option one is to just get physical iPhones. This is a picture of some of the phones I've collected over the last 10 years. You don't really need that many. You probably need one or two. Ideally, you want one that's a bit older with the check-rain exploit, which is the boot ROM exploit for iOS. That's going to give you a lot more control over that phone and very good for debugging stuff. The pros of using a real iPhone for your research, obviously, is it's a one-to-one mapping. You do your research and you test it on a test phone, it's going to work on the real phone because it is the real phone. The downsides is that for a lot of the debugging capability that you're going to want to do, you'll need a jailbreak, and there hasn't really been many public jailbreaks in the last couple of years. So you're going to be kind of working with outdated software in a lot of cases. It's still kind of fine because the core kernel doesn't necessarily change a whole lot between versions, but if you're trying to look at super modern stuff, then you're not going to really be able to do that on a real phone. Instead, you might want to use one of the virtual phone solutions. So for this, we have products like Corellium, which do full iPhone virtualizations, or more recently, the v4.0 CLI project. This allows you to actually self-host a virtual iPhone on your Mac, and it boots an entire iOS instance. And obviously, the benefits of this is you get unrestricted debugging capabilities. You can do kernel debugging, debug any system process. You can run stuff as root with arbitrary entitlements. You can do it on any version, so you can even boot an iOS 27 device jailbroken. And it's also obviously scalable if you did want to do any kind of large-scale fuzzing projects. The only slight downside, it's not going to be exactly the same as the physical iPhone. It's pretty close, but you're probably going to miss a couple of kernel extensions for specific iPhone hardware stuff. And the third option is to use a Mac, one of the recent Macs, which uses the ARM64 chips. So iPhone and Mac now share the chipset, and they therefore as well share a lot of the code base. All of their frameworks and user space are almost identical. Most of the core kernel stuff is pretty similar. So it's actually, a lot of the stuff I do these days is actually just working directly on the Mac, and then the knowledge that you get from that transfers over almost one-to-one in a lot of cases to the iPhone. Yeah, so pros of that, debugging ability, because on Mac you can obviously run stuff as root, you can use arbitrary entitlements, you can debug real system processes. Again, same kind of downside though, it's not going to be completely the same. There may be some things that you lack that the iPhone would have. And then, of course, tools. I'm not going to spend as much time on this. I think this is a bit more obvious, but you're going to need some kind of disassembler or decompiler of choice to be able to take apart system components, because the iOS kernel, or the kernel extensions at least, are closed source, and you're going to want to take those apart. You're going to want probably a device, as I mentioned, that supports the check-rain boot ROM exploit. This will allow you to get full control over a lot of kind of debugging functionality and doing kernel instrumentation. So you want to use check-rain and Pongo OS, which is the kind of pre-boot environment that can actually allow you to load custom patches into the kernel and things like that. And then I just put a few other random things here that you can look at afterwards, some useful tools that I've used throughout my time. All right, so next let's actually move on to a hands-on task that you can indulge in if you want to start out doing something practical with iOS research. So the best task, in my opinion, to do when starting out with a new platform is patch diffing. So patch diffing is, for those who don't know, the process of comparing two versions. So we have an iOS version, and then we have the version that comes just after it, and we compare the two of them to identify the differences. And in the context of security, we're looking for where a security vulnerability was fixed in the newer version, and then by substituting these two, we can then find out what the bug was on the older version. Now, this is a really good way to get hands-on because you have to be working with the actual firmware files. It uses a lot of the same skill sets as actual vulnerability research uses, because you're going to be reverse engineering stuff, you're going to be trying to reach code paths, you're going to understand what the vulnerabilities actually look like. And I think it's just a very good thing to play around with to get familiar with iOS research. Yeah, so it's a great hands-on beginner task. So what do we diff? Well, Apple quite nicely organizes all of their patches per version on their security notes page. So every time they release an update, you can go on the Apple security notes and it will list all of the CVEs with some minimal information of what bug was patched and what component it affected. And then you can look through these and just find something that sounds interesting to you, start reverse engineering it and see if you can figure out what the bug was. So here's a bunch of random CVEs that were patched. This is from 26.5. You can see they give you kind of if it was in the kernel or if it was in a user space component, and it will tell you what the rough description of the bug was, if it was like memory corruption, if it was just denial of service, something like that. So we're going to look at this one. This is an image I/O bug. Obviously, we can see image I/O from the bold at the top. Image I/O is Apple's main user space framework for doing image parsing. So a lot of apps use this. And the impact is described as processing a maliciously crafted image may corrupt process memory. So this doesn't tell you a whole lot, but from that we can gather that this is probably one of the kind of interesting ones that we were talking about earlier in the context of messenger app exploits. Because if we can create a maliciously crafted image, being able to corrupt memory via a buffer overflow of some kind, this is exactly the kind of thing that would be used in one of those chains for a messaging app exploit. And credit goes to Yuri Ha and Arnie Hardison for the discovery of this bug. So to actually do the diff, you're going to want to download the firmware files, of course. So you can go to ipsw.me. These guys host all of the firmware files for all the Apple products. You can click on iPhone, and then we're going to be comparing these two versions. So this is 26.5, where the CVE was listed, and the prior version, 26.4.2, where the vulnerability presumably will exist. So we download both of those firmwares. Then we open image I/O from those firmwares in your disassembler of choice. So you can see here I'm loading it in IDA Pro. You want to load it for both versions, and then you can use a plugin such as bindiff for IDA Pro, which is specifically built to do binary patch diffing. So it will connect to your IDA database, and it will compare two databases to identify functions that were modified in between the two. So you run a bindiff on these two versions, and then IDA is going to give you a nice list of any function that changed in between those updates. So there's actually quite a few here. There was a few other CVEs in image I/O. The function we're interested in for now is this one. I actually didn't know this CVE was for this function, but obviously in retrospect now I've worked that out. But basically you would choose a random function that looks interesting to you and start analyzing it. So the function name is EXR read plugin decode block Apple EXR. So you already get quite a lot of info. You can infer a decent amount from this. Obviously this is involved with EXR parsing, so for the OpenEXR image format, and the specific function, decode block Apple EXR. So obviously it's involved in the decoding pipeline, exactly the kind of place you'd expect to see a parsing bug for an image format. So I've got the decompilations of both versions here. Now I've kind of stripped away some stuff to keep it simplified and focus only on the important part. So we have the unpatched version here, 26.4.2, and then the patched version, 26.5. And you can see that the patch is relatively simple. All that has been added is this integer overflow check right here. So this is basically checking that a multiplication did not overflow. And this check is missing on the prior version, which means that this big multiplication that consists of 4 separate values would be subject to an overflow, and it would go unnoticed. And the result of the overflow is actually used as the size argument for a call to malloc to allocate a buffer. So you can probably already see how this is going to be problematic. The result is used as the size argument. And through some further reverse engineering, I determined that those two values were actually the width and height of the EXR image that we supply. Then it gets multiplied by 4, and then it gets multiplied by this, which is the channel count, which you can also set to 4. So there's quite a lot of control over that. So if we were to substitute some of these values out, so let's say we had a channel count of 4, and then we had an absurdly large width and height, this multiplication is going to result in this value right here, which just overflows enough such that the bottom 32 bits are all 0, and this upper bit here is outside of the range of a 32-bit integer. So the effective result of the calculation becomes just 0. So classic integer overflow type bug. And obviously that size 0 is used in the malloc call. So we end up with a call to malloc with a size of 0, when it should be trying to allocate a very large buffer to store this image data. When you actually allocate malloc, when you do a malloc call with 0, I actually expected this to just return a null pointer or something, but turns out it actually gives you an allocation still. You just default to the smallest size allocation, which is 8 bytes. A few people I spoke to thought this is kind of odd behavior. I wouldn't have thought this would work this way, but it does. So you get a very tiny buffer of 8 bytes when you should have like something with a lot more bytes. And then what's going to happen is the image data, somewhere later in the decoding pipeline, this data is going to be copied over into that buffer, and you're immediately going to run into a big problem because the pixel data is much, much larger than 8 bytes. So we have a big overflow here, and all of this is just corrupting heap memory and causing a bunch of issues. So that's kind of all the theory out of the way, but how do we actually reach this to prove that it works, or to prove that you can trigger a crash with an image file? We first need a way to actually call into image.io. So image.io, as I said, is the main library used across iOS. Everything really calls into that. Any app that wants to do rendering of an image, it probably calls into image.io. You can also build your own harness around it to directly call into the function, which was more useful for me when I was doing the actual debugging into this. You get a bit more control over what you want to do. So there's a good harness code here, which actually calls into that draw image function, calls into the relevant image.io stuff. Again, link up there. This was pretty useful to debug this with. Then, of course, we need a sample image that satisfies the conditions that we consider to be triggering the bug. So obviously, we just have an EXR image with these huge dimensions. That's all you need, nothing more complicated than that. And then we can run this through the harness program or through a different process that uses image.io. And you see we end up with a crash right here. So there's our vulnerable function somewhere down in the call stack, the one where the integer overflow occurred. And you can see the crash occurs a bit later, and we crash on a classic OX414141, which those were the bytes I stuffed into the image file. So clearly we have a massive heap overflow. Those bytes corrupted something of importance, some pointer, and then there was some dereference to that pointer which triggered this crash. And also, you can run it on the Photos app on iOS. If you try and open this app, or this image on the Photos app, it crashes the Photos app. So this actually happened I had to update my phone to actually fix this. Every time you launch the Photos app, it tries to render it, so you cannot get into your photos. And also the Previews app on macOS, if you try and open the image, you're going to get the same crash, because all of these things are calling into the same code in image.io. So I've not done much more research into this specific bug beyond that, to be honest. So I just have a proof of concept that can crash that process. But it's potential that this could be reachable through zero-click if there was a vector that would render that image via notification. Maybe that's something you want to play around with. Of course, this bug is actually patched now. I have the proof of concept on my GitHub if you want to play around with it on an older phone. And there's actually more details. I already posted a blog on my website at zygosec.com where I covered more in depth on the breakdown of how I went about reverse engineering and diffing this bug. So check that out if you want to see some more technical info. So what should you do next? Well, I would recommend obviously playing around with patch diffing. I think that's one of the best things to do starting out with iOS research. Other things you can do is to study past research from other security professionals. So there's a lot of great blog posts out there where people explain in great detail how they have exploited a kernel bug or a sandbox escape or whatever, and you can follow along with that, buy an old device and try and re-implement it line by line. You can study the in-the-wild samples and the great research that comes from like Project Zero. And the key component is pretty much just re-implement as much as possible. I think reading and watching talks and reading write-ups without implementing doesn't really get you very far, at least in my experience. So I'd highly recommend doing something hands-on. And if you want something immediately to do now, just this week, Apple released 26.6. I think it was on Monday or Tuesday. So this is just fresh release. And this update has 87 CVEs. So if you actually want to do patch diffing, like the process we just looked at, then this is a really good update because we very rarely see this many bugs patched in one version. So there's probably some really interesting stuff there that you can diff and play around with. Yeah, that's basically it. I don't know if we've got time for questions or if I've gone over my time, but.
Questions?
At the beginning, thank you very much for that really nice and interesting presentation. One question, I really wonder, concerning sandboxes, I thought, well, yes, that, and I think you said that also, that a sandbox is something like an isolation for an app. That means that an app is isolated, at least at the beginning. And what I really found strange once was that Instagram knew that inside the Facebook app I was already logged in with my account and asked me whether I wanted to log in with the same account inside Instagram app. And I found actually strange how that would be possible.
Yeah, so I think I kind of know what you mean. I don't know the specifics of that, but I'm assuming that's something to do with like shared bundle identifiers. If they're made by the same company, you can have kind of, I know there's some keychain stuff that can be shared between those. So it doesn't actually, you couldn't do that with a random app, but I'm assuming it's because of that. I don't know the implementation, to be honest.
At least the Instagram app no longer suggested my account when I deleted the Facebook app. That I realized, yes, but thank you.
Of course.
You mentioned about the test devices, v4 CLI and the M1 chip, M1 chip MacBooks. What's the difference in between that? Because v4 C needs M1 chip. So the way you mentioned, like, what's the difference in between those two?
Between using the vPhone and between just using the Mac?
Yes.
There's probably not a whole lot of difference between the two. I guess you just get the full iOS environment. So any slight differences that you would see from doing debugging on a macOS framework or something, you're just getting it in the actual iOS environment. I don't know beyond that, to be honest. They might be very similar, yeah.
I have a question.
Yeah.
Do you have a recent bug that is your favorite, at least when you could talk about, that maybe you were like, the elegance of the bug or how it was exploited was like inspiring?
I don't know. I mean, I guess some of the stuff I've covered on my YouTube channel, some of the deeper technical stuff. I mean, the Pegasus, the BlastPass stuff, I think was really cool. I have a full breakdown on that, on how they actually shape the heap just through parsing for a dictionary that's embedded in the PK parse, and then they have everything such perfectly aligned in memory that you have. It's exceptional quality engineering, and to know that that was used in a reliable way in the wild to just send a message to someone with an image, and the fact that that would reliably do what it was supposed to do is very impressive. So the engineering behind that is very respectable. Yeah.
Cool. Thanks.
Hello. What's the most similar bug that could be also exploited on Android, on iOS? What do you think? Like, you've probably seen many bugs. Yeah.
Well, iOS and Android, there's probably a lot of overlap when you're talking about the deep concepts of exploitation. So I have done some Android exploitation as well, and most of the fundamentals of binary exploitation are completely transferable between the two. So you'd see the same types of bugs, like integer overflows that lead to heap overflows or use after freeze. You see race conditions. You see the same techniques like heap spraying, trying to spray certain objects into memory and align things to overlap pointers. All of those techniques, I would say, are actually like they're pretty version or like platform agnostic. So you see that across everything. I wouldn't say there's any like super unique bug that you wouldn't see between the two, actually.
Maybe black box wise, or like lock screen bypass, physical access?
Maybe. I've never looked at anything like that. I've only ever, basically the stuff we discussed is my like only area of focus. So yeah, I really wouldn't know in terms of lock screen bypasses.
Thank you, Billy. Round of applause.
Thanks a lot.
All right, it is now time to wrap up OFT numero quattro. Eins, zwei, drei, vier. Again, thank you from myself and Andy, the Objective-C founders. Again, briefly to reiterate what we do, the conferences, OBTS, definitely put that on your radar. Just really want to mention that a lot of people who first attend an OFTW then go on to attend OBTSs. So keep that in mind. It's 3 full days of training, 3 full days of talks, really get more into technical content, super cool. Check out the tools, the books. You got a copy of the first book. The second book is also fully available online for free. It dives into writing tools to detect Mac malware. So if you're interested more into programming or creating security tools, it's a great resource as well. All of this is available on objectivec.org. Again, we've made it to number 4. Stay tuned. We love doing OFTs, and so they will be more in the future. So keep your eyes and ears opened for that. I do also want to mention the OBTS scholarship. So I briefly talked about how OBTS is kind of the next step after an OFTW conference. We know attending an OBTS can be expensive, time-consuming, complex, and so to help facilitate accessibility, we have the OBTS student scholarships. You can learn more about these and, more importantly, apply to them on the Objective by the C website. I will say that we really enjoy when people who started at OFTW apply. Many applicants do get accepted, so put it on your radar. We do OBTS every year. In the US 1 year, back in Europe the 2nd year. So if you apply and you don't get accepted this year, when we're back in Europe, definitely consider applying as well, because logistically, there's a higher likelihood for the European conference. Important links. One of our favorite things about these conferences is that we get to connect with y'all. Makes me very sad when I see someone and never see them again. So you can keep in touch with us in a variety of ways. I mentioned our Discord channel. It's a great place to post questions, continue the connections. The YouTube channel, we post talks from the OBTS conference, but also we'll be posting these talks as well. So if you want to catch up on some of the talks, check that out. We're also on LinkedIn and X as well. We will also be posting the pictures and slides from today. Give us, a few days, a little bit of time. But if you go to objectivec.org, OFTW, v4.html, the content from today will be made free and accessible there shortly. Now comes arguably the most important part of the closure, which is thanks to many important individuals. First and foremost, we want to thank HPI. Without their generosity and great organization skills, we would not have been able to host this amazing conference. Specifically, though, I do want to take a moment to recognize some individuals that have gone above and beyond to really make this conference a reality. So I want to start with Professor Jiska. If she can stand, let's all give a big, big round of applause to Jiska. Not only many of her students were up here speaking today, doing trainings. She was also super instrumental in getting funding for this event and actually making it happen. So we literally would not be here today if it weren't for Iska. I also want to thank Melanie, Lena, Svanya, Nicole, the AV crew, and Berlin. Again, organization of conference runs smoothly when there are many individuals involved, and so a round of applause for all these individuals who, again, made this run so smoothly. Continuing on with the thanks, we want to thank the trainers and the speakers who donated their time and their expertise to give free talks and free trainings. A lot of these individuals are often giving talks and trainings at other conferences and charging a lot of money. So the fact that they were willing to volunteer and donate their time and resources for free is incredible. So a round of applause for our speakers, trainees, and panelists. Finally, have to thank you all. We could plan the best conference, but if no one shows up, it would be a bust. So again, we really appreciate you taking time out of your studies, your work, your trainings to come hang out with us the last 2 days. Also, keep sharing your thoughts on X, on LinkedIn, on social media. This exposure really helps attract new students into the community and also is great for our supporters. Speaking of our supporters, these are the companies and products that support the Objective-C Foundation. Running a foundation, organizing conferences is obviously not a free endeavor. So without these companies, without these products, we also wouldn't be here today. So if you know anybody who works at these companies, give them a high five, say thank you so much for supporting the Objective-C Foundation. We wouldn't be here without them. And now, the most important person to thank is, of course, Andy. I'm the one who gets to stand on stage. She hates when I do this, but I'm doing this anyway. So I'm the one who gets to stand up on stage. Everyone comes and says, Patrick, that's such a great conference. I get a lot of the credit. But behind the scenes, Andy is organizing 99.99% of the entire event. She started working on this 6+ months ago, many emails, organization. So the fact that this ran incredibly smoothly is all thanks to her. So one more round of applause. All right, now we like to end with 2 things. We do a little giveaway, and today the 2 things that are going to be in the contest are pretty straightforward, and our giveaway is some more bags and some more books, so you can share with your friends or your colleagues, or if you just want another copy. So the first one is, the question is, who is from the furthest away? So this is kind of hard to start, but if you're from somewhere that you think is reasonably far, that you came from just for this event, raise your hand, shout out, and we will try to figure this out. So I'm guessing outside of Germany. Boston. Wow. India. Okay. Brazil. Oh, man. Okay, how are we going to figure this out? Do I ask chat? Can you ask chat and we'll get back to this? Okay, perfect. Well, welcome, foreigners. Really appreciate you making the effort to come from such a far distance. That's incredible. And we will get back to a winner. Now, the second question I think is easier to figure out. We always like to figure out who the youngest attendee is. So again, is anyone under, let's start with 19? Okay. Oh, I only see one hand, so 19 and a half. 18? Okay. 18. Okay, so I think we have a winner. Andy will give you a bag and a book. Thank you for. Yeah, come up. We'll take a picture. When I was 18, I was not doing cool hacking stuff. So congrats, and stoked that you were starting your hacking career so early. Let's smile for the cameras. Awesome. Thank you for attending. All right. Boston, Brazil, India, come to the front. Chat has said those are all equally as far away. But regardless, we want to celebrate your long flights and dedication to attending the conference. Yes. Here. And a book. Hope it fits in your baggage. Yeah. Give you one of these. Great to meet you.
Thank you. Likewise. Thank you.
Perfect. For you. For you. Bag for you. Awesome. Quick photo. Squeeze. Awesome. Thank you again for coming so far. All right, so now what we're going to do, listen very carefully, is we are going to take a half-hour break. Right outside, there are drinks, beer. Yes, okay, don't leave yet. Shortly, though. Drinks and food. So we'll break for half an hour. You can have some drinks, have some food, and then after that, please come back because we are going to do a panel where we are going to have some very interesting individuals answer some questions, but you will also be able to ask questions. So it'll be super interactive. The stuff they're talking about is super relevant to careers in cybersecurity, AI, and some interesting topics. But before we do that, we are going to get together for a group photo. I think that's the last thing here. So you can start making your way down. We have an amazing photographer, Nicole, who is going to tell us what to do. Also, if you do not want to be in the group photo, that is totally okay, but don't be shy. Okay, so everyone come up on stage.
Hello? Hello, hello? Yeah. Okay. Okay, everybody on the stage, please. The taller people in the back. Okay, everyone. So everyone has to see me, so I can see you. So find a little gap. That yes. If you can see me, I can see you. That looks great. Okay, I wait a second, we have time. Find a place. Great. Okay. That looks good, really good. Give me a second. So, look at me. Okay. I count 2, 3. 1, 2, 3. Yes, you can show me your sign. That's perfect. And again. Yes. Nice. And again. And give me a smile. Yes. Perfect. Thank you so
AC. All right, so for the last part of the conference, we are going to have a panel. I'm going to let our esteemed panelists introduce themselves, starting with Professor Jiska.
Hello, it's my pleasure to be here and having this conference here. And I'm a professor here at HPI, leading the mobile and wireless security research group, doing all kinds of iOS, Android security research. I also have a mobile security course and an IoT security course, and a bunch of seminars, labs, thesis, and, well, shout out to my students. So, yeah.
Hello, my name is Ksenia, you already know me. I'm a research engineer. I'm really happy to be here with you guys. I'm glad to meet many people here today during the lunch and during the break. It was awesome to talk to you. Can't wait for questions.
Perfect. Hello. Hi, I'm Greg. You just saw my talk, probably, or were in my training, or if you don't know, I do file system security mostly in the Apple Security Bounty program, and that's all I do. I call it Fun Employed, and I feel like the odd one out of this panel, but we'll see how this goes.
Awesome. So the focus of this panel is finding your footing in Apple security. So all of us here have different unique paths, as is common, getting into Apple security. So the goal is for us to kind of explore some of our differences, commonalities, provide some advice. So I have some questions that I'm going to ask each of the panelists, and then we're going to open it up to questions for you all. So, kind of as I mentioned, everyone's path is different, but yet we're all here on stage with a lot of similarities. So starting with Professor, what was your path that got you into Apple security? How did you get to where you're at now? Where did it start? Let's share with us, please.
So it was a bit unexpected. Like, it was during my PhD that I was looking into Bluetooth security, and turns out doing meaningful research on Bluetooth security within software-defined radio was difficult. And then I got into firmware reverse engineering to modify the chips and the way how the wireless protocols behaved.
Okay.
And that then brought me into iOS and Android security, because it turns out that, like, if you want to have a very nice stack that has a bunch of interesting features, maybe also like proprietary features, and if you want the latest chips that have these features, support these features, then you need to go to mobile. And so then it was like, it was around those checkmate times and so on, and it was like, good times.
Good times. Very interesting. Ksenia?
Yeah, I started with Apple security like almost 3 years ago. In cybersecurity, I started from threat intelligence. It was mostly about abusing Google products and Windows stuff. I wasn't into Apple security much. But then I had an interview in MacPo, and they said that there is a big problem with Apple security researchers because there are not many of them, and for them it's really hard to find the professional, and they decided just to start raising their own professionals. Yeah, that was my path. They gave me the chance. They said, you have 3 months to read Patrick's book. I said, okay, deal. Finished it, and that's how I made it to...
Love it. Greg?
The question is how I got into Apple security?
Yeah, like what kind of, inspired you focusing on Apple stuff?
Right, okay. Well, I wasn't going to. No, seriously.
Fair, it's great.
No, that's the truth. I'm not like an Apple person, which is, I think, this is why my answer might be a little bit interesting, perhaps, is that at the time when I started this, it was a lot of events going on at the same time. The Apple Silicon just came out, and I read the reviews, and it was apparently awesome. And thankfully, the Magic Keyboard was gone, which was not awesome. And I made the choice of like, hey, this system is getting popular, and and I thought that reading the reviews and everything is that Mac is going to just go up. It's going to be ever more present, and there's going to be more and more of this. And coincidentally, a friend was visiting, and I looked at his Mac, and I started messing around with it, and it had tremendous code smell. And I'm like, I think looking into that, and maybe if the Apple bounty actually works, because I didn't believe that it would be, and I gave it a shot, and it worked, and I'm here now. So, yay!
Love it, love it, love it. I mentioned this to some of my students in training, but people often ask me, like, Patrick, how did you decide on Mac? And the answer is it was a very lucky decision. So as some of you know, I started my cybersecurity career at the National Security Agency, the NSA, and there I did some malware analysis, exploit analysis on the defensive side, and then I transitioned to the offensive side, which was super fun, kind of badass, but also gave me insight into how advanced nation states thought about performing offensive cyber operations. And at the time, everything was focused on Windows. That was just one of the predominant operating systems that NSA's targets were running. When I left a few years later to start a company with some friends, I wanted to still use my foundational skills, reverse engineering, malware analysis, but when you leave the NSA, you have to be a little careful because all the work you're doing is classified, and so you can't disclose any classified information willingly or unwillingly. At least you're not supposed to. And also, if you discuss publicly about anything you did, even in non-classified terms, you still have to get it pre-published or pre-pubbed. So if I wanted to give a talk on analyzing a Windows malware sample, even if I wasn't using classified techniques, I would have to submit it to the pre-publication office, wait some amount of time, and then publish it. And so I said, okay, well, this OS 10 Mac thing is kind of like coming up. This was, 20 plus years ago. And so I remember I got my first MacBook. I bought it from a random stranger in a Burger King parking lot off Craigslist. Yeah. I didn't have any money, and it was a great deal. I didn't ask any questions. True story. And so I started digging into it, and very quickly I found that it was a platform that was intriguing to me, that was really untapped. And so I had situations where friends were asking me to help disinfect their Macs, and I was very familiar about how to do that on Windows. For example, I knew about sysinternals tools that I could run that would show me what persisted, auto runs, etc. But on Mac, there was like none of those tools. And so I started creating those to protect my own systems, help my friends disinfect themselves, and I guess the rest is kind of history. I just fell in love with the platform, and here we are today. But in retrospect, it was a very serendipitous decision, I guess thanks to the NSA, so forever grateful. So the next question, also about kind of getting into the space. What was the most helpful first step? So did you have one single thing that you found early on that really helped? Was it capture the flag, contributing to open source, pursuing a degree, attending events, publishing research? Once you kind of decided, okay, I'm interested in this Apple security stuff, what was something first that you found super interesting? We'll start with Professor again.
So probably before anything Apple, because that was rather late in my career, but like when I was 13 years old, the dad of a friend of mine just said, hey, there is a Linux user group in this town, and like you could go to their meetup. And so I went there, all of them were older than me, and it was like, but they were super friendly. We're like, okay, you're going to be our next hacker and whatnot. And and so it was not this like, oh, you don't know anything, please go home. They were just fascinated that there was like a young girl wanting to know like how things work and interested in it.
It's amazing.
I had such a good time.
Wow, very cool. Ksenia?
Yeah. What was the question? I remember that my first steps in Apple security, how was it? I mean, actually, it was a little bit problematic because there are not much information regarding Mac, like not much courses or something. Or if there are, they are super expensive, and you're like, how to do that. Okay, you can go to Hack the Box or try Hack Me wherever, but there are almost nothing about Macs. And yeah, as I said, your book helped a lot, and actually the real practicing with my mentors, my team. Yeah, I had really nice engineers in my team, and they gave me a lot of their knowledge. And first 3 months, guys, I was crying a lot, to be honest. Because I was sitting from like early morning until 11 p.m. or midnight, like from 8 a.m. until midnight. My mom was like, just drop it. It's like, wow. My mom was like, I can't see it anymore. I was like, no, we're gonna go further. And now it's better, much better. So these very first months, yeah, you just need to dedicate yourself to learn more stuff. And Greg mentioned during the talk that the more time you spend, the more skills you have, and then the kind of the path not easier, but kind of more, you are more confident. Yeah.
Yeah, it's. I could go a couple of ways with this question. I would go with the personal way. To me, the biggest thing was the people. That you could look this up, and I did look this up, and I had a bunch of like Linux experience and whatnot, but before this, for a decade, I ran my own company, and I was dealing with business people and SAS and all that kind of crap, you know, and coming back here to meet people where everybody's nice and everybody just wants you to succeed, and just connecting to those people who share the knowledge for free, people who truly want to better the world, was something that I really, really missed. And to me, one weird thing happened. I started reading the blogs of Wojciech, of Csaba, of a bunch of amazing researchers, and Csaba's name came up, and I'm like, that sounds, I think he's Hungarian. And I reached out to a friend who knew him, and he reached out, and my first bug took Apple like 14 months to fix, and it was a collision. And every month I would message Csaba, just full caps, like, completely losing it. And because he's an actual adult, in true Csaba fashion, he's like, calm down, it's gonna be fine, they will pay. We did this for like 9 months. And they did pay. Well, eventually, they didn't pay for that one, but I found a bypass, so they eventually ended up paying. But literally, if it weren't for these people, I wouldn't be sitting here. So to me, that was one of the biggest things.
Awesome. I love that response. I guess for me, my first experience that kind of got me into the cybersecurity space or the hacking space was, I remember in high school, we had these TI-83 graphing calculators. And it was like Calc 1, Calc 2, we had exams and we were allowed to use our calculators, but the teacher would come around and check to make sure we didn't have like the formulas programmed into the calculators so we could just plug in the numbers and it would solve for that. And I said, ooh, I'm gonna do something sneaky here. And so what I did was I wrote a simple program, and I think it like calculated the digits of pi, where you could then, it would ask for input, and you could put in a number, and it would tell you what the digit of pi was at that number. So if you put in, 4, it would be 3.145, whatever it is. But if you put in a special number, it would open up this like backdoor secret menu with all the mathematical formulas. And I remember I did this over spring break. Yeah, I was a super cool kid. But the funny thing comes when the exam happened, since I'd spent all spring break teaching myself to program and had implemented all the algorithms to solve the integrals and whatnot, by the time the exam rolled around, I fundamentally knew these equations so well. I'd written tests and everything that I actually didn't need that. And so it was good because I didn't actually end up cheating, which is always a good thing. But it was really eye-opening to me, and it really showed me that I had this very inquisitive mindset, that yes, I kind of wanted to, stick it to the man and figure out what I could get away with, but also I had a fundamental love of learning. And so that really inspired my study in computer science, taking a job at the NSA, and then kind of getting into Macs. I think my first Mac experience was, and I mentioned this to my students in training, I had a friend who I just mentioned whose computer was hacked and his MacBook, and I went over and I knew how to analyze Windows malware. Mac malware was like a new experience for me. So I went home, wrote a tool to kind of fill in the gap, and then I brought that back to his computer, ran the tool, and it pointed out the malware with some persistent adware. And the cool thing was he was a surfboard shaper, so as a thank you, he shaped me a custom surfboard, which I still have. And so I was like, huh, maybe this like Mac nerdy stuff is gonna pay off. But more so, I realized that there was this gap in the space for these tools, and if I needed them, there was probably others out there. So that really inspired me to kind of go along and really open up a lot of doors and got me deeper into my Mac career. So that was a very helpful first step for me. So the next question is about reality check. So from the outside, looking at careers in cybersecurity, sometimes they look very flashy and sexy, and you get to travel the world, and you talk about 0 days and making lots of money. But sometimes there's misconceptions, and sometimes reality and what actually goes on behind the scenes is different. So my next question is, what is the biggest misconception students have about working in cybersecurity, maybe Apple security, right? Is it the work maybe not as glamorous? Maybe not everyone finds 0 days. Maybe the reality check is you find a cool bug and Apple bug bounty doesn't want to pay out. So what are some kind of reality checks that I think it would be good to discuss that students could be aware of? And again, start with Professor.
Yeah, so I supervise a lot of theses for students, and then it's like for a bachelor thesis, 3 months, for a master thesis, a 6 months project.
Okay.
And usually they did play some CTF before.
Okay.
But doing a thesis is very different. Like for a CTF, you kind of have this bug guarantee. So you know, like you put in a few hours and you will find the bug, or you will at least find a write-up where someone like, you know, posts this. And I mean, there kind of is a bug guarantee no matter what you look at, because things in IT are just like horribly broken. But
good job, security.
Yes, but like the thing is, like, even if there's bugs, you don't know where they are.
Sure.
And like there's no guarantee, even if you do very good work and develop a very good method, that you will find something. Yeah. So you might work very hard on it and like just not get this. And that's something that's not really visible. Like what's visible is like when we stand on stage and present something and say like, these are the 3 cool bugs I found. But like there's so few people who talk about like, and this is the 10 other things I tried that didn't work. And maybe like there should be a bit more about this culture of also talking about these mistakes. It's surely like not as flashy, but it would be teaching a lot, just like learning the approach, knowing it's normal to fail.
Yeah.
And because of this kind of misconception, like there's another thing that comes with it. So because students are used to play CTF or something, like they get this reward, this feeling of you found something. And usually in a thesis, there's this tipping point. Like the first time you find something, then it goes like all up. And
but until then.
Yes, but you need to stay motivated until then. And you don't know, out of the 6 months, it might happen in the 5th month. Yeah.
Wow.
And then like, you know.
Hang in there.
Yeah. And then like, I know like, I just keep saying like, you know, I have the confidence that this will succeed, this will be a cool thing. But the students also have to have this confidence in themselves. Doesn't like it's not only me saying this, but they need to make it happen in a sense. And yeah, that's so yeah, maybe it's just talking more honestly about how long some of the projects take and how much didn't work is probably the misconception.
Yeah, I love that. It's, you know, it's not all glamorous and there's a lot of time in the trenches. So Ksenia, you mentioned crying.
No, I do not cry anymore because you guys invite me to your events. So
tears of happiness.
Yeah, it worth it. So I agree with all Jessica mentioned, and from my side, I think there is one more thing that is kind of frustrating because all the time you have to deal with legals, law, and other stuff like that. Sometimes you have like motivation and everything. You are very like, oh, I'm going to. I see like I know hacker servers. I'm gonna hack it, get all the information from there, and blah blah blah. And I'm going to do that. But actually you can't, yeah, because there is a law and you can't do that. And some students, they think, oh, well, that's fine. I'm going to hack that. I'm going to dark web. I'm going, you know, and you have to think about like law side of it and like, yeah. And that's, it's kind of frustrating thing because sometimes even hackers, threat actors, they just leave their open directories, yes, and you can go and see the stuff there, and you're like, okay, I'm going to publish like the report about that, like I saw the malware, saw everything, but you see there is some sensitive information. They, for example, stole data from people and there is PII, and you just can't publish it because you gotta tell anyone. So it's like the big responsibility, and before doing something you have to think twice, yeah.
It's a good answer. Don't want to get in trouble with legal.
Just trying to help you avoid troubles.
Those are both very, very good points. I don't even think about the legal because it's, but yeah, that is very important. The things, also failure is that I alluded to, that I routinely call myself an idiot, and you guys don't think I am because some of you walked up and was like, are you okay? It's like, yeah, I'm okay. It's like, you know, I'm like 70% joking. But because I do this and I come here and I'm obviously gonna show the things where I was successful, and the things that are funny are not gonna be the things that were truly difficult. Because it's not exciting to see a man bash his head against the wall for 6 months. Like, there's not much to learn from that except for persistence or stupidity, depending on how you look at it. But so you didn't see this, but I saw it because I was there, right? So like, for every single thing where you succeed a bunch of times, you fail, and you will think that you have failed, and then you might be tempted to think that you're not for this or whatever, blah, blah. Doesn't matter truly, because most of the time, if you do things right, you will succeed eventually, if that's possible, and even if not, even if you truly fail, you have learned, which in my book is, again, not really failure. Sometimes you do everything right, and the universe things just don't align, and you get unlucky, and that's fine. That's one. The second one is that, like this kind of imposter syndrome, this thing, we all have it, and it doesn't go away. But it's also something that keeps us going and keeps us striving for more in like an unreasonable way of like what is enough. And then, like personally, at least, maybe this is just me, there's like no such thing as enough. There's always a new challenge, there's always a thing, there's always a new dopamine high. At least that's how I structure my life, which in retrospect, saying this out loud might be wrong. But I think that's for career building or something like that, just having incremental successes will keep you in the game. It will keep you from you know, truly burning out.
I like that. I'm going to echo your first answer specifically, just the persistence thing. I love to write books, and you know, people often like, how was it? And you know, it's like at the end when you're doing a book signing and people are saying how much they love it, it's an incredible feeling. But you know, to get there is a slog, and even if you love the material, it's just it's a marathon. And everyone told me it's going to take twice as long as you think. They were absolutely right. And so the reality check is you sit down, oh, you're going to write a book. It's on a topic you love. This is going to be amazing. And the reality is, no, it's very daunting. And that really what gets you through is the persistence. What Professor Yiska said, that she tells her students when they're searching for issues, bugs, what Greg mentioned as well. And you know, people often ask me, you know, Patrick, some of your successes, what you attribute it to, and it's always just persistence. So the book example, I'm like, okay, I'm going to write 500 words a day in, day out, weekends, even when I don't want to, and eventually that adds up to a full book. Who'da thunk? And so just the reality is things take a long time, things are difficult, hacking isn't always sexy, and the persistence, I think, is something that carries us through. So yeah, kind of what Greg says, even if it's super frustrating, you know, you run with it. And I've really found even if I'm not motivated to do something, the act of doing it kind of brings the motivation. So often we think that I need to be motivated to do something, and it follows in that way. I like thinking it the other way, where sometimes just the action is what triggers the motivation, and then it's this feedback cycle. So next question I want to ask is, this is maybe a little simpler ask or answer, what your work day actually looks like, either a work day or a work week. They all kind of come in different roles. We have bug bounty hunters, malware analysts, professors. You know, I think we have students who are thinking about all those paths. And so, you know, a given week, what are some of the things you enjoy or you do that are kind of unique to your path and where you're at now?
So maybe a bit trolling, but I think we all have the same job. Like we all answer emails, check our Slack, but like, you know, yeah. But besides this, like what I enjoy about my job is like I work with young people and guide them through their career. So it's a lot of talking to people. And now with the professorship, like the weird thing is I qualified for the professorship for doing highly technical things, and now I have to do more management, like getting funding, planning someone's PhD thesis through and thinking what they could do for 3 years or even more, like this kind of stuff. So that's like a lot of my job right now. And then like thinking about, you know, which kind of technology or question would be relevant even in a couple of years from now.
That prediction.
Yeah, so it's still technical, but like more in the sense of thinking wider and planning.
Sure.
Yeah, and like during the PhD, it was much more, I would say, technical and more like things were my own responsibility.
Okay.
It was more like you have that one thing that you hack on or in a team or something like it. Just it shifted a bit, but I like both. So it's yeah.
And now you probably maybe have a broader impact where you're making
and that plus like that's the research part, and then of course teaching, which is like also something that helps me, right? Because when I explain something and then I see like, okay, where do I have gaps in my explanation, or like where are things that I still don't know and maybe it's a research topic.
I like that. Awesome. Ksenia?
So my day is not like fully about like security only and malware. Malware actually is like routine, and we do not count it even because I work in a product. It's a security product. We need to research, find new solutions for better detection. We also need to implement new features. We need to brainstorm these features, etc. We have a lot of cross-team collaborations with our developers who works on an app. It's always designers with data scientists, etc. Like also marketing team, brand team, who sometimes come to us and they're like, we need a comment for this for 9 to 5 Mac, for example, or someone else, you know. And also like customer support, because we have customers, and sometimes customers are like, oh, I think that that's something suspicious, but then you check, it's actually not, but we still need to check because we are also curious, so maybe it is something suspicious and something new we haven't seen before. So and all this stuff, a lot of stuff, and a lot of meetings, of course.
I like it, a lot of variety. Greg?
You're really putting me on the spot with this question, man. It's fairly uncomfortable because so to answer this properly, I have to admit, like a grown-up, that it is dangerous to work from home and have no responsibilities.
What a problem.
Because this is, that's the insidious thing.
True.
You think this is great until you haven't left the house in a week. And your mental and physical state is just absolutely disintegrating in front of the eyes of your loved ones who are truly worried about you. It's not as dramatic. It's not as dramatic. I'm playing it up a little, but that has happened. Depending on what I have to do, most of this is self-driven.
Okay.
which is difficult for me due to various reasons, ADHD and whatnot. But also that allows me to do and come up with a bunch of stuff that might not occur to somebody else. So I'm like quite okay with it. But generally speaking, it's a difficult thing to do because if I currently have nothing, then I need to find something. I know, groundbreaking, right? But if I'm currently working on something that I have found like a good primitive or a good thing that really just pulls me in, it's really easy for me to stay motivated because I wake up, it's like, fuck yeah, I'm like one more day of this, to the tune of I will like forget to eat and stuff. Wow. And then I wonder why I'm dizzy because that's the part where I'm an idiot, yes? So like, that is good when you can, or at least my brain can attach to something like this, and then you succeed, and then you have a POC, and once you have a POC, you just optimize, and then you have to write the report. It's like, wow. All right, fine. Least favorite part of the job, but you write the report and you submit it.
You need an agent.
And then you wait. And then you look for something else. And that part of discovery of like, what's the next thing? What do I even look for? And when I had nothing, as in knowledge and already ready paths and utilities and you know, stuff that I could look for, I would be lost. So this is generally when you just like look for other people's works and it's like, oh, I wonder if this pattern exists, you know, somewhere else, and you start looking for that specific thing, or you start doing these. And eventually you spend enough time and you fail enough times where you find a partial chain, an interesting behavior, a very weird edge case, and this starts to pile up in your drawers. And then you start to combine them, you start to figure out how to put them together and what other stuff to look for, and that drives you forward. But basically, if it's like a daily routine, it's like depending on what I have to do, I just like sit in front of a computer a lot, which is really bad, really good sometimes, but you really have to be self-disciplined and just like make yourself do the things that you don't want to do, because to me, at least, if I'm in the middle of a research project and I'm just like on the cusp of discovery, it's unbelievably difficult to drag myself out of that.
Wow. You're hooked.
Yes, in more ways than one.
Again, I ask one thing. When you're writing the report, I have problem with reports too. Like whenever I need to write it, it feels a little bit frustrating. And to do that, usually I have to leave the house. I have to go somewhere else, to some place to just, you know, because when I go to the restaurant somewhere, I can't stay there for the whole day. I'm like, okay, I have 2 hours, kinda, yes? So I have 2 hours to write this thing, and that's, I have this like kind of pressure to help myself.
Yeah, we academics have established a ritual around this. It's called paper submission deadline. And that's like the 1 week when we actually work more than 40 hours, and then everything gets written.
Of course.
No, that's actually genuinely a really good way to do this. Yeah. I found like so like there are many things that I could be doing. I could be doing discovery. I could be doing the optimization. I could be doing exploitation. I could be doing some other type of research, or just mess around if I don't feel like it. And I disallowed myself from feeling bad because I'm not doing what I'm supposed to be doing. Oh my God. Yeah. So like I used to feel bad about that, and now I'm just like, yeah, I'm not in the mood for that. And it's just like, I felt like a petulant child of like, you have the best job in the world, you get to do what you always wanted to do, and you're just not in the mood for it. You know, like grow up. But then I figured that if I start to force it, A, I'm not gonna be productive, and B, I'm gonna burn myself out. Yeah. So instead of that, it's just like, hey, okay, look, whatever, I have like 100 or 200 or however many things that I wanted to look into. It's like, how do I feel like today? And I know that sounds insane, and it is insane, but it helps. It helps because that allows a certain part of my brain to recharge and then wake up tomorrow and then do in 5 minutes what would have otherwise taken me 6. And writing is one of them. I actually enjoy writing, but you'll see if I'm any good. But it's interesting because I don't want to do it. It's not as dopaminergistic as like finding stuff. Sure. But what I found is that I can write for 6 or 7 hours and don't feel as tired as if I did exploitation. Maybe because I'm an egotistical idiot and I enjoy it, or I don't know, but leaving the house, changing the environment, maybe like going to a place where you know you're not gonna have internet. Go on a long plane ride. You will want to not waste that time, but the only thing for you is to just, okay, I'm just gonna write this up. That's what I used to do.
I like it, I like it. The next question's kind of answer one of two. So a lot of students are thinking, okay, landing my first job. A lot of companies these days want to see portfolio projects or external research that students have done. And so any advice to students, what is one small project that a student could focus on to create maybe an open source project that could illustrate their capabilities, their skill set, and also even maybe align with that, how do you help students identify, research ideas? I feel like, Professor, you would be excellent at answering this question. The guidance, do you try to find what they're interested in, or you try to, like you said, you look at the technology and point them in that direction? How do you kind of resolve that?
So I usually have, like a ton of ideas in my head, but the problem is like, when does the person appear who has the skills to do the thing? So usually I just try to talk to the student and figure out like what is their expertise area, and then to find something that matches this. Because for a thesis you have to spend 6 months on one thing and you need to stay motivated throughout it. So it has to be a match, and like if it's not like, then yeah, it's just not gonna be fun. So I usually ask them like if they are more like, low level system or high level, or like which just kind of stuff they generally like. And that would then direct a bit like what I would suggest them. Sometimes it's even the students who have a nice idea. Yeah. And then of course, like, why not? Like if we can make it work as a project, why not? Because that's the best motivation, right? Yeah, it's true. Something there. Yeah. And the other thing is, I think university already gives you like a ton of ways to make such projects, right? There's like so many courses where you do have to make some project submission, the thesis, but like at HPI we do have a master project before that, and a lot of courses just generally grade you by a project. Yeah. And if you choose wisely, you can always do something that you can publish on GitHub at least, and that's just a bit of your own choice, as well as much as, depending on in which group you are, you might even get support. So I try to support my students, so they submit to OBTS and you get swamped with all the submissions, right? Like, so it's, and that's the whole idea of like, supporting people by giving them a project that they can actually also talk about, that they can publish. It doesn't always work out, but like, at least in a lot of cases, like it does, and I try my best, and I think that's it from the student side as well, right? You can think about like, oh, there is this project work in my course coming up. I just vibe code the easiest thing to just get a passing grade, or you're like, okay, this is going to be my next school project. I will put this on GitHub. I will promote this on social media. And I will put this on my CV, and if later on in my job interview, like I get asked about like, is there anything cool you did? And then you can just talk about like, there's this and that project. Yeah, why not? It's a bit of extra work, but I think like these days, the job market gets more competitive, and you need something that sticks out. And you just, by just having the courses completed with low effort, probably that's not the way.
Not gonna cut it, yeah. No, that's really good advice, having something that they can point to that is a differentiator. So, Ksenia, imagine someone was applying to MacPaw. What would be like a research idea or portfolio project that would you would be like, okay, this person gets it. This is a great candidate.
Actually, Patrick, I had some conversations here with students, and I would say they already have pretty cool ideas and projects. I was like, oh wow, about like phishing, click fix stuff, etc. So I was really impressive, and sometimes it feels like maybe students can have even like more fresh view on some stuff. And as a recommendation, maybe you can just poke around to find any pain points. Yes, like Reddit, Twitter, where researchers kind of hinting on something they struggle with.
Okay.
Like me and Chris saying about Go Garbled.
Yeah.
I mean, anyways. You can just find this information and turn it into your project, yeah? Because people need automation, people need solutions for things they do not like. Whenever you go to a new company, you see immediately tasks that no one wants to do. So to be kind of to stay there for a long time and got promoted, you have to take these tasks because it's like the way where you can develop.
Those are really good answers. Honestly, yeah, the fix problems for other people is amazing. Now I don't have anything to say. So HR is fundamentally dysfunctional. I don't know if you guys know this. HR doesn't really work very well most of the cases. And ultimately, the people who are going to be making the decisions, at least in like smaller companies, are going to be generally the engineers or generally the people that you would be working with. And passing the HR filter is a skill and a task in and of itself, especially now. But passing the test of the engineers is going to be something else. And I interviewed lots of people, and it wasn't great. I didn't like doing it, but I had that job for a while. And I sat on every single situation. I was an interviewee sometimes. I was an interviewer sometimes, and I was, the developer who had to find another teammate. And in almost every single case, the person that got my attention and tended out to be working out very, very well is somebody who was passionate about what they were doing. And that, in my belief, ties into that if you're passionate about something, you will want to do it, you're motivated to do it, you will do it more. And the more you do it, the better you get, the more you want to do it. And it's this self-fulfilling prophecy. I think, in my opinion, I might be absolutely wrong here, but generally, if you can find something that is really your passion project, even if it's dumb, even if it's objectively worthless, I don't mean it that it's worthless totally, but like monetarily cannot be monetized. You wouldn't make money with it. But you poured like 500 hours into this dumb project and it's working really well. It's just like not something that, for example, you could build a startup on. If you have something like that, or if you have pursued something like that and you think it was a gigantic waste of time, I posit to you that it's not. Because you're going to show that to some other engineer and they're going to look at it as like, oh, that's awesome. And the next sentence is going to be, too bad, that's not going to make you any money. But your goal in this situation is to get better, to hone your skills, to spend the time, to acquire the knowledge, and then to be able to demonstrate that. And that's what I wanted to say in my talk of like, even if you think it's not worth publishing, it might be worth publishing, but your solution is so much better, and Jiska's solution is so much better.
I love all those answers. So the next one, we have to talk a little bit about AI because, it's the hotness.
Yay.
But no, I think this is a good thing to dig into. So I want to touch on just AI and foundational skills. Do you have any advice for how students should use AI tools to accelerate their learning, if at all, without allowing these tools to hide gaps in understanding, without falling into I'm just going to have the AI do it all for me? Because, I think there's pros and cons to AI. It can be super empowering, but sometimes people can use it as a crutch. So any advice that, you give to your students, or, Ksenia, you use at work, like where people use it too much or not enough? I'd be really interested in your professional opinions, personal opinions, professional opinions, on AI, the goods, the bads.
So I think there is one very weird thing with AI. Like, if you're not an expert in a topic, then the AI output always looks very, very good, very plausible. And you'll be like, oh, that looks amazing. I don't have to learn this because AI is better than me. And I can see that it's like, it's taking a ton of effort to get better than the AI, but this is the people that we will need. We will need the people who do not just, do very basic programming because the AI can do it. We need people who can evaluate what the AI was doing, who can steer the AI. And so we need a higher skill level, actually. And I'm not sure if you can just skip all the steps in between or not.
Said.
Yeah. Future will tell. I'm also very scared of this fact that, right now it's difficult to get entry-level positions, right? Because everyone says, well, entry-level AI can solve it. I don't hire the people. But in 5 to 10 years from now, where are we? If AI does not improve tremendously, then we will need senior people. But how do we get seniors if you don't, someone has to hire the juniors. And so I hope, even though right now it might look a little bit not so promising, but if you keep on track, if you keep learning, I think, especially the fact that right now there is this drop in hiring entry-level positions, if you say, I don't care, I love this, just do it and get to this expert level that will be needed so much in a couple of years, and don't give up on the way. I know it's hard, and it's I have a safe job, and it's easy for me saying, yeah, in 5 to 10 years it's going to get better. But yeah, please stay on it, and please stay motivated.
That's great advice. Ksenia?
So AI is, I have a citation, sorry, my English is my fourth language, so.
What a flex.
So the quote kinda about the any poison, if it's in small amount, it's kinda a cure. So it's kind of with AI the same thing. Yeah, if you use it normally, not that heavily, that AI does for you everything, it's cool. It's really helpful, and it speeds up everything. That's really nice. But we had a situation, even few situations with candidates that were going to junior positions, and they thought that we can't see that they use AI during the interview. It's it's a misconception. So do not do that, because we can really tell that the person uses AI. Some person joined, for example, from phone and try to use a laptop, and we ask to share the screen, something, So it's better to not do that. It's better to learn stuff before, and even if you use AI, use it be the human in the loop still.
Sure.
That's my point.
You are so right about that.
Thank you.
It's I don't know. First, I hate AI. Listen, no such thing. It's LLMs. Let's just stay there. They're not thinking. They're going to say they're thinking, but they're not. If they're thinking, we're in trouble. If they're truly thinking and getting smarter, it's going to be a Skynet situation, and I don't have good news for you in that case. If that does not happen, then this will become another tool which is going to be useful. Now, an AI, you can think of this as a mentor that has a lot of time and is pretty patient, but is also a pathological liar, okay? So whenever you can ask it things, it's going to explain things to you, and generally, if you use it like Google, and you just use it to extract information or parse something or give you ideas, I think that's valuable. I think that's good because I did mess around with it. It did help me get through hurdles where, you know, where I was like falling into rabbit holes that would have taken me like 4 or 5 hours. And then it's just like, no, actually you missed that part. And I'm like, oh, that's cool, okay. Wow. But if you become overly reliant on it, you will get dumber. Like at an absolutely astounding speed. I saw this in myself. You get lazy really quickly. And it will mislead you in very subtle and insidious ways. And then you will spend a day figuring out what went wrong. In which case, just the fundamental assumption or just the fundamental approach to solving a problem that the AI took was not actually correct. And then you're not going to know this. So even if you ask it, it tells you the answer. Make it tell you how it arrived at the answer. Reproduce that. Use that. Test it. I know it's painful, it sucks, it's learning. But if you don't do that, you will end up in a weird spot where you think you did all the work, but in reality it was the AI. And I'm not going to bring up like plagiarism or cheating or whatever. I'm just going to bring up a very, very simple economic thing that if the AI did your job, you're worthless. I'm sorry. Because everybody else can use the AI, and everybody else does, and everybody else did, as evidenced by the changelogs that came out 2 days ago, 700 bugs, 20-way collisions, which was absolutely unheard of. Because everybody was like, hey, I'm just going to throw a $120 per month cloud subscription at Apple, and I'm going to use it as my personal ATM. And you think you're really clever, and apparently 19 other people had the same idea. So if everybody has the tool, it's going to raise the floor, but true expertise will still matter. At least I really hope so, because otherwise I need to look for some other gig.
Wow. I love all those answers. I have nothing to add because that was incredible. All right, and I want to open the floor to you all. We have 10, 15 minutes or so. So now is your opportunity to ask us anything. You can direct questions to specific individuals, ask open-ended, you know, career advice, cybersecurity questions, anything else. Now is your chance. Yes?
You know I like to get my money's worth.
Ha. Oh. Good toss. Quarterback.
I'm too far from my AI. I won't be able to ask the question. I'm just kidding. Of the companies that were listed as sponsors for this conference, there was one company whose name I didn't see, the Apple Corporation. So I'm curious about your guys' interactions with the Apple Corporation. How do you interact with Apple? And I'm interested in all of it. Really, I mean,
great question.
I've heard from, I have some understanding about Greg, but you know, Ksenia, as you're working for a vendor of Apple software, like, well, you can talk more, but all around, I'm curious about that. And what is the interaction like between the Objective-C Foundation and Apple? And like, if a student gave a great presentation at a conference that's put on by you guys, would they get like cred or like points with Apple? Like, would that be a way for people to get there?
I love that question. I'll start by answering the Objective-C specific stuff and then defer. Yeah, it's a question with multiple answers, multiple facets. I'll start with the positive. So first, we've had a lot of really great experiences with Apple. And one of my favorite stories is there was a woman in Ukraine, Yulia, who was doing some really great Swift programming, malware analysis, reverse engineering, publishing on her blogs. And you know, so I was chatting with her, mentioned the conference was coming up, and encouraged her to submit to the conference. The committee selected her paper. She flew to Maui. She was understandably a little nervous. English was not her first language. She hadn't spoken at a big conference before. So I spent some time chatting with her. She gave an incredible talk that had a ton of like great technical insight, really a lot of new perspectives that the attendees really liked, and she was a great, engaging speaker. Shortly afterwards, Apple, who was present, hired her. And first I was like kind of bummed because like, man, we lost the speaker. But working for Apple, she was able to relocate from Ukraine, first to London. Now she works for Apple proper in California. Super stoked. And so this is a great example because all we did was give her an opportunity to shine, to let the world see her capabilities. And Apple picked up on that and gave her an incredible opportunity, an incredible career that she's super stoked on. More so now, she's a great role model. I think Ksenia might be able to talk to this too. Like, traditionally, cybersecurity careers, maybe for women in Ukraine, weren't something that thought was super obtainable or something that was the first thought. And so having someone like Julia as this role model, this great example, like, that's incredible. So yeah, like I said, I was kind of bummed that they hired the speakers because when you work at Apple, you can't generally talk about what you do, which I'm like, okay, that kind of takes away from the community. But it's a great career opportunity, great role model, and then also opens up new opportunities for other speakers. Also, I always say, we wouldn't have a conference if not for Apple. So it's one of these things that, what could be done better? Yes, I would love for Apple to be supporting the foundation. But in a way, they support in other ways. They release buggy code that gives us stuff to talk about. But no, kidding aside, they show up, they interact with us, they recruit, which is amazing if they're hiring students, and the speakers, it's a great opportunity. So, give them an 8 out of 10. I think they could collaborate a little bit better. The collaboration is also a little bit one-directional. So if I encounter some new malware, a new exploit or something in the wild, I'll give it to Apple. Apple sometimes in their XProtect, which is their built-in AV, will release a signature for a new malware sample that we don't know. We can reverse engineer the signature, see the YARA rule. It doesn't hit on anything the rest of the community knows. I'm always like, it'd be great if you could share that information with us, because Apple's YARA signatures are pretty conservative because they can't afford to have a false positive. The downside is the adversaries can and do adjust and easily bypass their signatures, where third-party security products, I think, could sometimes add an additional layer against the new threat. But Apple generally isn't willing to share that. So there's room for improvement. My biggest complaint is that everything we share, it's like they don't share back. And I think that's just a company policy. I generally have nothing but great things for the individuals that work there. They're brilliant. They're making the world a better place. And at the end of the day, we're all on the same side trying to make Mac and iOS more secure. But great question. I don't know if you all want to add something to that, your experiences with Apple, good or bad.
Yeah, maybe like not so much about experiences, but like in general, something that's also important is like, of course, like sometimes people ask me like, is Apple sponsoring the research or something? And like, no, they're not. But I think it's kind of a feature because it means that I'm independent in what I research. And
good point.
Like, you have seen, for example, like Niels' work, I was supervising them in their master's thesis on this Apple Watch interface. And now, like, why would Apple sponsor research where we open an interface, where the European Union asked them to please open it, and they said, no, we tried for 3 years, it didn't work. Like, this is the kind of stuff where there would be quite a lot of tension if that was sponsored. And so, like, it is good to have this distance in a sense.
Silver lining.
Yeah, but like at the same time, of course, like I would like to look more on the inside because like, of course, also my students, they open like bug reports, and then like there's just, it's like in the void, and then the ticket stays open, and it's like unresolved, and you're just like, what the hell is happening behind the scenes? You don't know. So it's of course a bit of that as well. So I think more transparency would be nice.
Be great.
But yeah, like at least, and that's also something like early on we have been talking about like legal consequences of doing some research, and Apple does not, like, they allow reverse engineering for good faith security researchers, which is much more than other companies do. Like,
that's a great point.
If you do security research, depending on what it is, you actually like have to fear the consequences. So yes, they're like not monetarily supporting it, but they are also not standing in our way, which is
pros and cons.
Yeah.
I like that. It's a great answer. I hadn't thought about it like that, so that's a really interesting perspective. Thank you.
Yeah, answering the question about Magpie and Moonlog. So Moonlog is an antivirus app, and Magpie, we just, in Magpie, we develop apps for macOS and iOS. I can't say that we are Apple's vendor. No, we just develop apps. And actually, interaction with Apple from our side is kind of okay. I know that Magpie has some contacts there, but if we are talking about Objective-C Foundation, I can definitely say that we already got some good things from collaboration with Patrick and Andy, because when they when we did together Objective for the V in Kyiv, two persons who were attending the Objective for the V, they actually became my teammates, and now they joined the team like 6 months and then 12 months after.
Okay.
But they mentioned that, oh, we were there, and actually, whenever I post the one photo, one of my teammates is like, I'm on the background, by the way. Photo from
Origin story.
For the Wii. So yeah, that's not only Apple can hire you here, but like other cool companies can give you cool opportunities. So yeah, it's worth it to come here and participate. Yeah.
Thoughts on Apple, Greg?
Interacting with Apple is a little complicated, but I can sit here and tell you a bunch of bad stories, and frankly, most of it would be whining, because at the end, I don't think we've been wronged many times. I used to say that Apple never wronged me. That changed a little bit, but they sometimes change the rules and they change the TCC thing, and it's fine to do that. I just really dislike the way they did it, in that they didn't consider the researcher community. And when I say that, I talked to them after, because they started, responding to emails record quickly after it blew up on Twitter. And I think that wasn't necessarily intentional. I don't think they truly considered the impact that would have on the researcher community. But yes, more transparency would be great. However, I do understand why they do things like this. They can't just tell a researcher something, and that researcher just immediately runs to the media with an out-of-context sentence. And then it just like drags Apple's share price down a percentage point, which would be quite a significant amount of money. So they're not going to risk that, which is fairly obvious. All right. If you can put that aside and put aside the lawyerish communication and the frustrating experiences, I think it's still worthwhile to do this. Otherwise, obviously, I wouldn't be doing it. Personally, everybody from Apple who I met was the coolest person. They're really nice. They wanted to do what we want to do. And sometimes, a lot of things I can't repeat, obviously, but sometimes somebody hinted at the fact that us exploiting stuff and reporting it through the program, costing Apple money, is a good thing, because they can use it to internally justify putting more time and effort and resource into it. And what you will forget, I think, which I did certainly, is that Apple is not one big entity with a bald guy sitting inside a volcano, just being evil. It is a massive, massive corporation with hundreds of thousands of people, many teams, many incentives, many political things, and not actual political, but inner political things and turmoil and whatnot. So there is no such entity as Apple. Like, there's the things you see, there's the outwardly seemingly stupid decisions that are made sometimes, and sometimes those are just what happens when you try to coordinate this many teams and you have deadlines and you end up doing stupid things. On the contrary to that, Apple does support the community because Microsoft has the funds, has the need, and doesn't really operate a meaningful bug bounty program. Android, of course, is structured differently, but Google's bug bounty program, again, is not nearly as extensive as Apple's is. And there's a bunch of other large companies out there that flat out do not have a bug bounty program or don't have a bug bounty program that you would want to spend your time on. So I would like to make the case that maybe they're not so bad guys after all, even though they frustrate me. They really do. But like, then again, they're still doing their best, I believe. Patrick, I would like to believe. What do you believe?
I like that. Yeah, I think it's, the other thing is we're seeing it just from our side, and so there's a lack of understanding because of their lack of transparency. So exactly like you said, some of the decisions they make may not make sense to us at all, but they have maybe thought of the repercussions, but internally XYZ doesn't add up. And so, like I said, I think overall they do right, but there's always room for improvement. And I think the transparency and collaboration, improved communication, that seems maybe naively to be a very easy thing. Maybe it's not, because it's your point, then it could get out of context. But the times they have, for example, when they do talk at security conference, it's super well received. Everyone's really positive. So I wish they would kind of lean into that a little bit more. And maybe they will.
May I add something? Greg made a nice point about that Apple is not like one person, but a lot of teams. And sometimes I had typical like that problem with other vendors, not only Apple, just because we wanted to collaborate, we wanted to do joint research, we wanted to do joint presentation somewhere, talk somewhere together, and the researchers are so cool and they're like, yeah, of course, let's do it, I'm up to it and everything, and we can start collaboration right now, but other teams, kind of legal, PR, like marketing, wherever, they kind of sorry, no.
Wow.
And after like a week or something, the person comes back and I'm so sorry, but they don't allow us. So that's not only Apple's problem, but other companies as well. That's the business.
But if anyone here works or knows anyone at Apple and they want to support the foundation, that would be amazing. All right, next question. Yes, Lucas. There's the ball, or the square. What's its name, Eric?
Okay.
Lucas.
Yeah, thank you for your interesting insights. I just wanted to connect to basically the last question you asked, Patrick, regarding the AI. Kind of a question for all of you. Would you consider, like, if there's now a bug with 20 collisions, as we've seen, or like a vulnerability, should we even consider this as private, or is it something that basically everybody can find and it's just out in the wild?
I'm sorry, could you repeat that?
Yeah, so you mentioned there was a bug collision with 20 submissions. So if everybody is basically able to find this bug, should we even consider this as just like a private thing, or can you already consider it as being out in the public?
Ooh, good question.
I mean, you don't know if which of the bugs is the one with 20 collisions before, right? And I think there's also a lot of prompt engineering involved. So maybe if the prompt is just find me a bug in, I don't know, Safari, right? And then you can repeatedly see that across multiple models, it would always point you this one vulnerability, then probably, but even let's maybe look a little bit into fuzzing, because fuzzing is something we have bug collisions with fuzzing. And we might see now the same with AI, we don't know yet. But in fuzzing also a lot is about the fuzzing harness, and depending on that you might find different bugs in different targets, and it's I would say the same with prompt engineering and with new models and so on. So we don't know yet. If we would treat each vulnerability found by AI as public, I think it's currently not making things better. But at the same time, knowing bugs were found with a very trivial prompt, we should probably handle them more urgently.
Okay. Yeah, thanks. I'm just going to vote back.
can I add to that?
Yeah.
Sorry. So the thing is, I think so there's like two things going on when you say consider public. As in like fully disclosing it public, or what do you mean by that?
Like treating it with knowledge that some other people also might be able to find this quite easily.
What would that mean in practice? Because okay.
Yeah.
And maybe fixing them a bit more urgently.
Right.
Yeah.
Yeah. Well, yes. What I heard, from my perspective, treating them public means that if I treat something as public, as it's, i.e., it's already known, it's no longer a 0-day, then I'm free to publish it. Now, when I'm publishing something that's I think is public, but not actually, I might be the one making it public unintentionally. Now I have legal responsibility. Now I might be publishing cyber weaponry, which is a lot less important than I make it sound. But then I would get in trouble. And as far as Apple's concerned, if I drop a 0-day publicly, they would kick me out of the program, and every current submission that I have, every money they owe me would go to zero, and I will be permabanned for life. So yeah, so that's something to keep in mind. Sorry, I just wanted to add that bit.
No, it's interesting. I wonder too, from the offensive side, exploit brokers, right? So, imagine someone's going the other route and selling to an exploit broker, and if I'm an exploit broker, hypothetically, I would say, did you find this with AI? And if the answer to that was yes, I would assume that it's probably going to be patched quicker, or maybe someone else is going to find it and report it. So I might be more brash to quickly use it in the wild and or pay less. I mean, these are just kind of assumptions, but I would imagine that the offensive side is also having that same question. I don't know what the answers would be to that, but I'm sure that they are thinking, yes, if we can find this with AI, or the person selling us found it with AI, someone else can too. But I agree 100% with Yiska that it's prompt engineering, and then also what was said earlier, the experts with the AI, they might be kind of a step above, and that might be the winning combo. But I do think in general it increases rather the likelihood that others are going to find it.
I actually have a question, but there is probably no answer. If AI is that cool in finding bugs and POCs and everything, why threat actors are still posting on the dark web forums messages about, is someone selling this kind of CV, like POC, to that CV or something? If they can use just AI and go to CV already published, for example, but there is no POC in the wild. So they could just go and produce it with AI, but they do not do that, maybe because for a reason, maybe because they tried, as was mentioned, with give me this, and it didn't work. So that's just my question to, myself. And
Wanna hear my theory? My theory on that is that they have more money than skills or patience, because cybercrime pays well, unfortunately. And I think it's easier for them to say that, hey, I'm going to throw 10 grand at this problem in Bitcoin or whatever, solve this for me, I don't care how. I think that might be the case, if I had to think, but I'm just taking a shot in the dark here.
Yeah, but it still means that not everyone can just go and do it. The person needs to have a patience.
Yeah, to Greg's point, maybe more of the cyber criminals are they're writing the malware and distributing it. They're not finding bugs. But you would still think that there are bug finders that would sell to them, and why aren't they using AI? So, interesting. Question?
Patrick, this one is for you.
Awesome.
From everybody that I've spoken to who's been to the conferences, you see that the community is growing a lot. Where would you like to see it grow in the long term?
In the context sorry, I think I missed part of that. specific people who attend, their careers?
Not necessarily in terms of the size or the people, but where would you like to see the organization as Objective-C, where would you like to see it grow?
Yeah, no, that's a great question. And it's something we ponder because I was talking to some students earlier where after the conferences, especially OBTS, I like to ask people what they liked. And the obvious answer is, well, the location is great, the talks were amazing, but people said, we love the size of the event. We love how everyone's so approachable, your speakers are top tier, but because the conference almost seems somewhat intimate, like I can just go up and talk to, you know, this really well-known speaker, and they're super stoked to talk to me. And so the challenge is, you know, and that's largely because the community is amazing, yes, but also the size makes that more realistic. And so I think the challenge becomes, how do you grow, because there's always going to be more people that want to enter, and we want to welcome them with open hands and arms, but at the same time not lose kind of the size. And so I think our approach is just kind of grow slowly, but also do more events. The other thing we've learned, the complexity of events grow exponentially with size. It's amazing. For example, this event had the university, Professor Yiska, just like, you know, it's incredibly helpful. But for OBTS, it's mostly Andy and I, mostly Andy. And so, you know, going from a 200-person conference to a 400-person conference is definitely more than twice the work. So that's something we ponder. And I think the idea is just grow slowly. To answer your question, where we like to expand, I personally, and I know Andy agrees and we're super on the same page with this, the more accessible local events seem to really like check so many boxes. Like an event like this is incredible. It's, you know, OBTS is amazing, but a lot of people who are there are already like well in their career, and you know, it's awesome and great, and we all have a great time. But these events, I think, have more impact, and I think it's something that's super fulfilling, both to Andy and I. My dad's side of the family is all teachers, so I think it's in my blood to, you know, teach and connect with students. But just hearing stories of students and seeing where, you know, they first came to our conference, read the book, took a training, and then they were already on a great trajectory, but then that helped land them their first job, their career. It's just like those stories just are incredible. And so in terms of where we will go, I think just doing more of these Objective for the We events, it's something. And then from there, I don't know, we'll have to ponder. But because the other thing is like, don't break something that's working well or whatever the code is. But yeah, I think expanding that. And then the last piece of the puzzle that Andy pointed out the other day, which I think was really great, is connecting students with the companies that are looking to hire. Because we kind of have the trainings for the students, we have the conference, and so we do have companies who have informally come to us over the years saying, hey, you know, we post this job, we get, you know, 100 AI slop applications. We want a list of 5 curated candidates who we know are well-trained, passionate, and they're like, the kids coming out of your conferences and your trainings, those students and individuals really check a lot of boxes. So there's some efforts there to kind of close the circle and connect students with companies. And that's just like such a win-win. If there's a way we can help a student land a great job, that has the potential to like change their life significantly for the best. And then the flip side is these companies are still desperately looking for, you know, the best of the best, but very, I think, good candidates, and are struggling sometimes being overwhelmed with ones that don't match. So I think that's an area where we can improve and are working on. So great question, though. Awesome.
May I ask the question?
Of course.
I remembered about Objective-Steve.
Yes.
How is it going?
It is going well. We're going to have more news about that at OBTS. So we do have a program called Objective-Steve. The idea is it's about jobs.
It's not Steve, it's Steve.
Steve.
Steve. Oh,
yeah,
okay.
like Steve Jobs.
That was correct.
And the idea is, the idea there is to basically, as I was mentioning, connect more students who are actively looking, talking to companies, and kind of more formalizing the process. So we spend a lot of time talking to companies, figuring out what they're looking for, how willing they are to be involved. You know, it's one thing, the engineers are like, we want the dedicated candidates who are really good, and then like the hiring and HR people are like on a different planet, and so it's like, figuring out there. And so I think we've been learning a lot, and I think there's some efforts there that we've been working on that are going to be super exciting. Because at the end of the day, yeah, like my happiest thing is like connecting a student with their dream career and a company finding an amazing candidate. It's just amazing for them, and then it feeds back into the community. That individual works at that company, hypes us, they send speakers, they might support the foundation. It's just like a win-win-win-win. So a lot of work there, and I think in the near future we'll have some exciting announcements. It's a great question.
And one more thing, you can do like 2 conferences in the US and Europe at 1 year if you want to expand, but not with a lot of people. So you gotta split them.
Maybe. As Andy can attest, it's more work than meets the eye.
I know, like Objective by the Sea is such a great conference. It's pretty huge. It's not a small conference, so I understand that effort is crazy, and doing 2 at 1 year probably it's too much. Yeah.
But I think stay tuned. We will be doing more OFDWs in Europe. That's the tentative plan, and then also year after next year, OBTS will be back in Europe. So I think we have time for one more question. Yes, in the back. Launch it. This is like team building.
Wow. Look at them. World Cup.
Rugby.
Thanks for these talks. It's really insightful. You guys are really awesome.
Speak a little
louder. I have a question. Can you hear me? Oh, okay. Yeah, I said thanks for this talk. It's really insightful. I'm really enjoying it. I have a question regarding AI deepfakes. For some time now, AI deepfakes have been all over the place, and I haven't read I haven't seen a single article that proposes solution to this problem. FS ISAC, Financial Services Information Sharing Analysis in the financial sector, have been talking about this because they're losing the control. So it's like speed versus control. And I believe that we humans are incapable or biologically incapable of distinguishing AI deepfakes from reality. So do you think we need some kind of technology that can help us like cryptographically verify what is real and which voice is unreal and all that?
Great question. Any of you have insight into solutions for deepfakes, or what can we do?
Adding on to that, I think my question would be the last one. Have you thought about Apple releasing the glasses, like Meta glasses? Maybe that would be an answer for this question.
Oh, interesting. The deepfake, that's a tough one because, exactly, I think that there is no easy solution, which is why maybe we haven't seen practical ones being proposed yet. I think we're already seeing the downsides of that, and yeah, I think it has the potential to impact society in a lot of negative ways. Me personally, I just haven't spent a lot of time and study on that, so I don't think I have a good answer other than acknowledging and agreeing that it's something that is problematic and getting worse. I mean, even in the sense of cybersecurity, with these like fake employees getting hired into companies. I think it was like the financial companies you mentioned now are requiring in-person interviews as a way to combat that. So it's like we're almost full circle where we like went to remote interviews and stuff, and now they're like, no, you got to come back into the office, put on a suit and tie. We got to like poke you to make sure you're a real human until humanoid robots come around. But yeah, so I think in some senses just going back to the old school ways where in some cases that's practical, like job interviews, others it's not. But yeah, it's a really good point. I don't know if you have any other thoughts or input.
I mean, I think it's a very good example of how the AI just makes everything worse in general. Like
such a hater.
Yes, I'm sorry.
It's good. We're not going to all agree on
that.
that.
My blog. It's this interesting problem though, because Photoshop has existed, yeah. So what is fake, really? Like, if you want to screw somebody over with a fake picture, you could do that almost 100 years ago. Well, not quite 100 years ago, but you know what I mean. Yeah. Like you could go way back and start faking stuff. So I don't think that might have necessarily changed. What changed is the availability of the technology, of that now it is very cheap and very scalable, and the outputs are very good. So as to how to handle that, I haven't got a clue, mate. I don't think it's going to be something that we would be able to solve. And because currently, I don't think there's anything that would be able to solve it. I don't see like fundamentally how that would be even possible.
I think we should ask AI.
Oh, Jesus.
I've heard from friends that in companies that big tech companies that hire, as you mentioned, imposters, it's a big problem because, for example, the European law that protects data doesn't allow HRs or recruiters ask, for example, even during the interview to show the ID even, and well, that's it. Like, and you need to change the law at that point, or what? Like, it's just something that humanity needs to work on.
On that positive note, we are now going to wrap this up. Thank you for all your questions, and let's have a round of applause for our esteemed panelists. Two things. As you leave, please clean up around you. If there's any bottles or anything else, grab those, and let's leave this room spick and span. And then we still have some time outside to mingle, about half an hour. So grab some more drinks, talk some more stories, ask us all some questions, meet some new people. But again, round of applause for everybody, everything, the conference. Woo! Great insights. Fun, yeah. I need to buy this stuff.
Seriously. Hello. Ja. Ja, aber gestern hatte ich mit Region. Gestern? Ja.